Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a tool for you to practice for your entrance exams. There you will find a number of entrance exam question papers with their detailed solutions and PDF. You can also download our app. The link is available in the description box. So students, let's move further for solving TS EAMCET 10 September 2020, Shift 1 paper. This paper is having different sections. We'll be solving the mathematical part of this paper today, which is having about 80 questions, 80 mathematical questions. So let's start with it. A very best of luck. Here we go with question number 1. Let f be a function which is defined from 0 to 10. This is from 0 to 10 to 1 to 20. This be a function defined as fx is equal to this when x lies between 0 and 6. This is equal to 10 when x lies between 6 and 7. And 31 minus 3x when x lies between 7 and 10. So now this is which type of function? Bijective, one-to-one but not onto. Onto but not one-to-one function. Neither one-to-one nor onto function. So f is a function in which this is the domain and the range of the function. Domain is from 0 to 10 and the range is from 1 to 20. Okay. So here we have, see, fx is given to be 10 for all x belonging to 6 and 7. That means, see, so all x between, for all x from 6 to 7, this is having only one solution, that is 10, which means this is not one-to-one function. This is no one-to-one function, so this is wrong. Okay, B option is gone. This is not a one-to-one function. Now I'll pick up the second one. You're given that for x lying between 0 and 6. This is true. So let's say multiplying all the sides by minus 5, you will have minus 30 less than equal to minus 5x less than equal to 0. Let's add 60 on all the sides. So 60 minus 30 less than equal to 60 minus 5x less than equal to 60. So this is 30 less than equal to 60 minus 5x less than equal to 60. Let's divide all the sides by 3 now. Actually, I want to get to this function. So let's divide all the sides by 3. So 10 less than equal to 60 minus 5x upon 3 less than equal to, that's 60 divided by this 3. That's giving you 20. Okay. And 7 is less than x is less than 10. So now I have to get to this 31 minus 3x. So multiplying all the sides by minus 3, you will get minus 30 less than equal to minus 3x less than equal to minus 21. Adding 31 on, adding 31 on all the sides, you will have minus 30 plus 31 less than equal to 31 minus 3x less than equal to 31 minus 21. This gives you 1 less than equal to 31 minus 3x less than equal to 10. So that means from all of them, you get the range. Also, it's given in the question. Range of the function is 1, 20. Now it's given that it is given in the question that codomain of the function is from 1 to 20. That means range is equal to codomain, right? Range is equal to codomain of the function, which simply means that this is an onto function. Correct? That means it's not one-to-one, but this is an onto function. Option C is the correct answer. Hope you understood this. Then let's move to the next question, number 2. The domain of this function fx is equal to this is what? You're given the function fx is root of log 10 5x minus x square upon 4. For fx to be defined, this should be greater than equal to 1. That means 5x minus x square should be greater than equal to 4, or x square minus 5x plus 4 should be less than equal to 0. So let's split the middle term. You will get the two factors as minus 4x minus x plus 4 is less than equal to 0. X minus 4 minus 1 x minus 4 is less than equal to 0, or x minus 1 into x minus 4 is less than equal to 0. So that means if I'm drawing this on the number line, the two factors are x is equal to 1 and 4. So for 1 and 4, between 1 and 4, this is negative and it's positive on either of the side. Infinity and minus infinity on that side. Therefore, x belong to 1 comma 4. That means domain of the function is 1 comma 4. That is option B is the correct answer. Hope you understood this. Next is question number 3. Let the greatest common divisor of m and n be 1. If 1 upon 1 into 7 is plus this, up to 20 terms, this is actually 70 multiplied by 13, up to 20 terms is equal to m upon n, then 5m plus 2n is equal to. So here m upon n is given to be 1 upon 1 into 7 plus 1 upon 70, not 70 actually, this is 7. 7 into 13 plus 1 upon 13 into 19, so on up to 20 terms. So the general 20th term will be given by 1 upon 1 plus 20 minus 1 into 6 into 7 plus 20 minus 1 into 6. This will be given by 1 upon 1 into 7 plus 1 upon 7 into 13, 1 upon 13 into 19, so on till 1 upon. On solving this, this is 1 plus 19 into 6, that is equal to 115. Multiply 77 plus 19 into 6, that's equal to 121. So now further I'll multiply the numerator and the denominator by 6. I'll get 1 upon 6 into 6 upon 1 into 7, 6 upon 7 into 13, 6 upon 13 into 19, so on 6 upon 115 into 121. Now this further can be written as 1 upon 6 multiply 7 minus 1 into 1 into 7 plus this can be written as 13 minus 7 upon 7 into 13 plus 19 minus 13 upon 13 into 19, so on till 6. Okay, now this 6 can be written as 121 minus 115 in divided by 115 into 121. So further, this is equal to 1 by 6, 1 by 1 minus 1 by 7 plus 1 by 7 minus 1 by 13 plus 1 by 13 minus 1 by 19, so on 1 upon 115 minus 1 upon 121. So that is 1 by 6. You can write it as, see, these will cancel out, right? These will cancel out, so on. So you will be left with 1 minus 1 upon 121. That is 1 by 6 into 120 upon 121, which is equal to 20 upon 121. So that was equal to m upon n, which simply means m is equal to 20 and n is equal to 121. You had to find out in the question was 5m plus 2n, which is 5 into 20 plus 2 into 121, that is 100 plus 242. 342 is the answer to the question. That is option C. Hope you understood this. Let's move to the next question then. Question number 4, if A and B are two non-singular matrices of order 3, the determinant of B is equal to K, a positive integer, then match the list 1 with list 2. So we'll pick up all the options. Let's pick up the first one, A modulus of K inverse, A inverse. That's equal to K inverse. This is given by K inverse cube into determinant of A inverse. You know, determinant of A inverse is given by, that's equal to 1 upon determinant of A. So I'll use this thing in this question, that is given by 1 upon K cube into determinant of A. That is, see, K was equal to the determinant of B cube. That means this is equal to determinant of B cube into determinant of A, which is option 3. So this matches with A. I hope you got this. Let's move to the B option, that is adjoint of A inverse. Now, adjoint of A inverse, that is equal to, I'm using a formula over here. Let's discuss that formula first, that adjoint of A is equal to determinant of A raised to power n minus 1, where n is the order of the matrix. So that means this adjoint of A inverse will be given by adjoint determinant of this, sorry. Adjoint of A inverse is equal to A inverse determinant raised to power 3 minus 1, that is equal to A inverse raised to power 2, or that is equal to 1 upon determinant of A square. So this matches with this. So this is option B. Let's move with C now. C is B. It's given that B into A into B inverse is equal to identity matrix is equal to B into A raised to power K into B inverse. Okay, so now we know one thing, that BA into B inverse is equal to identity matrix, which means B into A inverse is equal to B inverse. So I have this thing, B A raised to power K into B raised to power minus 1. This can be written as B into K, A raised to power K minus 1 into A B inverse, which is equal to B into A raised to power K minus 1. This AB inverse was equal to B inverse. So that is equal to B into A raised to power K minus 1 into B inverse. So B A K minus 2 into B AB inverse, that is equal to B into A raised to power K minus 1 into B inverse. Now you're given in the question that this is equal to identity matrix and this is equal to B into A into B inverse. So I'll use this. If I pick up this option, this one, B. See, B option is, B option was B into adjoint of B upon determinant of B is equal to, this is B into B inverse, that in fact is equal to the identity matrix. And in this one also, this, that means this is equal to this. So this is option C. Hope you understood this. Next one is adjoint of adjoint A inverse. See over here, I would like to discuss this thing, that B A raised to power K into B inverse. This is equal to B into A into B inverse. That is equal to identity matrix. This was equal to identity matrix. So option 2 is also giving me identity matrix, which means option 2 is actually matching with option C. Now the last one, D. That is adjoint of adjoint A inverse. This is equal to C, A inverse raised to power 3 minus 2 into A inverse. You know one thing, adjoint of A is equal to determinant of A raised to power n minus 2, whereas n is the order of the matrix. So that means adjoint into adjoint of A inverse is equal to question number 4. If A and B are two non-singular matrices of order 3, n is equal to 3 and determinant of B is equal to k, which is a positive integer, then you have to match the list 1 with list 2. So let's pick up the first option, that is determinant of k inverse into A inverse. This is given by k inverse cube into determinant of A inverse. That is equal to 1 upon k cube into this. And k is equal to B, that's given in the question. So that is equal to 1 upon determinant of B cube into A determinant. So this is option A. Okay, A matches with 3. Next, option B, that is determinant of adjoint A inverse. That is given by, here I'll be using a formula. Let's discuss that. Adjoint of A inverse is equal to determinant of adjoint of A inverse is equal to A inverse determinant raised to power n minus 1. So here in this question where n is order, so let's go back to the question. So this is equal to determinant of A inverse raised to power 3 minus 1, that is A inverse cube, determinant cube. That means this is equal to this. So this matches with option B. Now this is with 5. Hope you got that. Next is option C. In option C, you are given that B inverse is equal to some identity matrix, and you have to find out B into A raised to power K into B inverse. This is what you need to find out in the question. Okay. So I'll pick up from here. Since you are given that B A into B inverse is equal to identity, so that means B A into B inverse is equal to B inverse. According to the question, now I'll get back to here. So here you can write this as B into A raised to power K minus 1 into A B raised to, B raised to power minus 1. This is equal to B inverse. Now this further can be written as B into A into K raised to power minus 1 into this, which is again equal to B into A raised to power K minus 2 into B inverse. So that means they are repeating themselves. That means B into A raised to power K into this is nothing but the identity matrix, which is again equal to this in the given question. Right. Now, if I look at the options, if you look at this option B into adjoint of B divided by B into adjoint of B divided by the determinant of B, that is equal to, see, this is equal to B into B inverse, because this is equal to B inverse, and that is nothing but the identity matrix. So that means you have B into A raised to power K into B raised to power 1 is minus 1 is equal to B into adjoint of A upon determinant, sorry, B upon determinant of B. So that's it. We have this matching with C part, or this is option 2. Hope you understood. Let's move to the last one, that is adjoint into adjoint of A inverse. So the D option was adjoint of A inverse. Now this is again equal to adjoint A inverse determinant raised to power 3 minus 2 into A inverse. This is because adjoint of A is equal to this, right? So where A is the n is the order of the matrix. So that means this is what this can be written as 1 upon A determinant into A inverse. So this matches with the option 4. So this is the one, right? So now let's look at this one, A3, B5, C2, and D4. This is option A. So this is the correct answer. Hope you got that. Next is question number 5. All the real values of P, Q so that the system of these equations have no solution, may have no solution are. Okay, you are given these three as the equations, and now we have to, if we express these equations in the matrix form, they can be written as A will be given by the matrix 2, P, 6, 1, 2, Q, and 1, 1, 3. B matrix will be 8, 5, and 4, and X matrix will be given by X, Y, Z. For no solution, determinant for no solution, determinant of A is equal to 0. That means determinant of 2, P, 6, 1, 2, Q, 1, 1, 3 is equal to 0, which gives you 2, 6 minus Q minus P, 3 minus Q. This is equal to 0, which gives you 12, 2 minus 2Q minus 3P plus PQ minus 6 is equal to 0, or 3P plus 2Q minus PQ. So I take this and Q from here. So you have 2 minus P is equal to 0. I'll take 3P minus 2 minus Q. This. So I have the two factors as 3 minus Q and P minus 2. So that means Q can be equal to 3 and P can be equal to 2. Yeah. Okay. So for P is equal to 2, equations 2x plus py plus 6z is equal to 8, and x plus y plus 3z is equal to 4. They are same, right? So P is not equal to 2, but Q is equal to 3. Okay, so P is not equal to Q, but Q is equal to 3. P is not equal to 2 and Q is equal to 3. That is option C is the correct answer. Hope you got that. Next is question number 6. If P and Q are two distinct real values of lambda for which the system of equations these have non-zero solution. So now these equations, they have a non-zero solution. Then you have to find out P square plus Q square minus PQ is equal to. So these are the three equations. Let's express them in the matrix form. So A matrix will be given by lambda minus 1, 3 lambda plus 1, 2 lambda, lambda minus 1, 4 lambda minus 2 lambda plus 3, 2, 3 lambda plus 1, 3 lambda minus 1. X is equal to X, Y, Z. Okay. For the non-zero solution, this determinant A is equal to 0, because here you are given the final matrix, that is B is equal to 0, 0, 0. So determinant of A is equal to 0. That means determinant of lambda minus 1, 3 lambda plus 1. Lambda minus 1, 3 lambda plus 1, 2 lambda, lambda minus 1, 2, 4 lambda minus 2, 3 lambda plus 1 lambda plus 3, 3 lambda minus 1. Determinant is equal to 0. Let's perform some transformations. Let's transform R2 to R2 minus R1 and R3 to R3 minus R1. So this will become now, okay, lambda minus 1, 3 lambda plus 1, 2 lambda, 0 lambda minus 3 minus lambda plus 3 minus lambda plus 3, 0 lambda minus 3 is equal to 0. So now let's expand this. You have lambda minus 1 into lambda minus 3 square plus minus lambda plus 3 into 3 lambda. I'm expanding from column 1. Expanding column 1. So minus lambda plus 3 into 3 lambda plus 1 into minus lambda plus 3 minus 2 lambda into lambda minus 3 is equal to 0. This gives you lambda minus 1 into lambda minus 3 square lambda minus 3. I'm taking common lambda minus 3 minus 3 minus 1 minus 3 lambda minus 1 minus 2 lambda is equal to 0. This gives you minus 3 lambda square. And here will be lambda minus 1. And here I'm left with minus, this will be plus 5 lambda plus 1 is equal to 0. Lambda minus 3 square multiplied by 6 lambda is equal to 0. That means lambda can have the values as 3 and 0. If lambda is equal to 3 and 0, see in the question, P and Q are two distinct real values of lambda. That means P, I'm taking, let's say P is equal to 3 and let's say Q is equal to 0. You have to find out the value of P square plus Q square minus PQ. So that is 9 plus 0 minus 0, which is 9. That means we have option B as the answer. Hope you understood this. Let's move to the next question, number 7. Now I have a complex number problem. Let Z is equal to X plus iota Y and A be the set of numbers, complex numbers, such that the magnitude of that is less than 2 and B is the set of complex numbers such that 1 minus iota Z plus 1 plus iota conjugate of Z is greater than 4. Then which of the following options belong to A intersection B? Okay, fine. So here in the question you are given Z is this complex number. So magnitude of Z is root of X square plus Y square. Now it is given that modulus of Z, A contains the set which is, for which this is less than 0. So that means I can simply write down for A set root of X square plus Y square is less than equal to 2, which means X square plus Y square is less than equal to 4. Let's say this is as number 1. Now from the B set, you are given 1 minus iota Z plus 1 plus conjugate of Z is greater than 4, which is A1 minus iota X plus iota Y plus 1 plus iota X minus iota Y is greater than equal to 4. Which gives you X plus iota Y minus iota X plus Y plus X minus iota Y plus iota X plus Y is greater than equal to 4. And this will cancel, these will cancel out, and you will have 2X plus 2Y is greater than equal to 4, or X plus Y is greater than equal to 2. Let's say this is as equation 1. Now you have to find out A intersection B. What was A set? A set said X square plus Y square is less than equal to 4 intersection with X plus Y greater than equal to 2. So now this belongs to what? Let's pick up option A to check whether it is satisfying the given sets. So A is root 3 plus 1 by 2 iota. A option is root 3, 1 by 2 iota. So this is X, this is Y. X square plus Y square gives you 3 plus 1 by 4. That is equal to 3 1 by 4. This 3 1 by 4 is less than 4. That's absolutely correct. Let's pick up the second one. X plus y. So this is root 3 plus 1 by 2. Root 3 is 1.732 and this is 0.5, which makes it 2.232, which is of course greater than equal to 2. So both the conditions, they are being satisfied. So this is the correct answer. Option A is the correct answer. You can verify the answers. You can verify for B, C, D options. This is X, 1 by 2 is the Y for this one. X, 1 by 2 is the Y for this one. 2 is X, 2 is Y in this case. You can verify all the B, C, D options. They will come out to be invalid. Option A stands to be the correct answer because in the paper, you don't have so much of time to check out all the options. It's okay. We got the first option as the correct one. So next is question number 8. The solutions of this equation where Z belongs to complex numbers lies on which curve? So the given equation is this. Now let's say Z square is equal to some omega and that is given by r cos theta iota sine theta where r is greater than 0. So that means this equation can be written as 1 minus z square is equal to 16 upon z square or z square plus 16 upon z square is equal to 1. So that means r plus 16 upon r cos theta plus iota r minus 16 upon r sine theta is equal to 1. Now, on comparing the real and the imaginary parts, so this is equal to 1 and this is the imaginary part, so this is equal to 0. Comparing real and imaginary part, so this is equal to 1 plus iota into 0. You have r plus 16 upon r cos of theta is equal to 1 and r minus 16 upon r sine of theta is equal to 0. Therefore, from here, either sine theta is equal to 0 or cos theta is equal to 1. Why? Because r plus 16 upon r is equal to 1. This is not possible. Correct? So that means over here, r minus 16 upon r is equal to 0, which gives you r square is equal to 16 or r is equal to plus minus 4. Since r is greater than 0, so I'll take up only the positive value and magnitude of z square is equal to 4. That gives you magnitude of z is equal to 2, which gives me option D as the correct answer. Hope you understood this. Next is question number 9. If z conjugate minus z conjugate forms a rectangle of this area of square units, then one such z is. So first thing, I'll imagine this complex number to be z is equal to x plus iota y. Then the three vertices of the rectangle will become from here. Okay, this is z conjugate minus z and minus z conjugate. From here, the vertices will be x comma y, x comma minus y, minus x, minus y, and minus x comma y. Let's form the rectangle now. X comma y, this is going to lie in the first quadrant. So here is x comma y. Let's say this is as A. This one is B. This is minus x comma y, C, and D. Okay, fine. So, all right. Now it's given that the area of the rectangle is this. So, area rectangle, you know, that is equal to length into breadth. Let's find out length into breadth. AB multiply by BC. Okay, AB multiplied by BC. So AB is equal to root of x minus x, that is equal to 2x square plus y minus that's 0 square multiplied by root of BC square. So this is the 0 square plus 2y square, that is equal to area, and this is equal to 2 root 3 square units. Okay, so this gives you 2x into 2y is equal to this, or you have 2xy is equal to root 3, which gives you x is equal to xy is equal to root 3 by 2. That gives you x is equal to 1 by 2 and y is equal to root by 3. So you have the complex number as 1 by 2 plus root 3 iota. Okay, so this gives you your answer. We have option A as the correct answer. Hope you understood this. Let's move to the next question. Question number 10. So this is a merger of trigonometry and the complex numbers. You have cos theta plus iota sin theta upon sin theta plus iota cos theta whole raised to power 8 plus this expression is equal to. So I'll not touch this one. Okay, you can write it as cos theta plus iota sin theta, and I'll take iota common from here. This will give me cos theta minus iota sin theta whole raised to power 8 plus. Now 1 plus cos theta can be written as 2 cos square theta by 2 minus, and sin theta can be written as 2 sin theta by 2 cos theta by 2, and similarly the denominator will be written as 2 cos square theta by 2 plus iota 2 sin theta by 2 cos theta by 2 whole raised to power 16. That is equal to, I'll take iota outside. So this is equal to 1 upon iota raised to power 8 cos theta plus iota sin theta upon cos theta minus iota sin theta raised to power 8 plus. Now cos theta will be cancelled from the numerator and the denominator. You will be left with, and 2 will also be cancelled. You will be left with cos theta by 2 minus iota sin theta by 2 upon cos theta by 2 plus iota sin theta by 2 whole raised to power 16. Now this is equal to cos 8 theta cos 8 theta plus iota sin 8 theta upon cos 8 theta minus iota sin 8 theta plus cos 8 theta minus iota sin 8 theta divided by cos 8 theta plus iota sin 8 theta. Now this will be written as cot 8 theta plus iota sin 8 theta multiplied by cos 8 theta minus iota sin 8 theta raised to power minus 1 plus cos 8 theta minus iota sin 8 theta multiplied by cos 8 theta plus iota sin 8 theta raised to power minus 1. Bracket close. Further, this is equal to cos 8 theta plus iota sin 8 theta cos 8 theta plus iota sine 8 theta plus cos 8 theta minus iota sine 8 theta cos 8 theta minus iota sine 8 theta raised to power minus 1. This is equal to root brackets cos 8 theta iota sine 8 theta whole square plus cos 8 theta minus iota sine 8 theta whole square. So let's open the brackets now. You will have cos square 8 theta plus iota square sine square 8 theta plus 2 iota cos 8 theta sine 8 theta plus cos square 8 theta plus iota square sine square 8 theta minus 2 iota sine 8 theta cos 8 theta. This is equal to, you'll add them and these two as well, and these two will cancel. You'll have 2 cos square 8 theta minus, see, iota square is minus 1, so this will be minus sine square 8 theta. This is equal to 2 cos 16 theta. So 2 cos 16 theta is the answer to the question. That is option B. Hope you understood this. Let's move to the next question then. Question number 11. Let S be the set of all possible integral values of lambda in this interval for which the roots of the quadratic equation this are all rational numbers and the sum of elements in S is. So the given equation is lambda x square plus 13x plus 7 is equal to 0. Here the discriminant, it is b square minus 4ac. So b is 13, a is lambda, c is 7. That means discriminant, which is equal to 13 square minus 4 into lambda into 7. This is equal to, since see, they are the perfect, it is given that the roots are all rational numbers. So this is equal to 169 minus 28 lambda. For the rational roots, D is a perfect square. That means That means 169 minus 28 lambda is equal to 0, which gives you lambda is equal to this. That gives you 1 upon 28. Now it's given that lambda lies in the interval. Lambda belongs to the interval minus 3, 7. So that means lambda can have the values as minus 2, 0, 6 only. So that this can be a perfect square. Question number 11. Let S be the set of all possible integral values of lambda in the interval minus 3, 7 for which the roots of the quadratic equation, these are all rational numbers. Then the sum of elements on S is. Okay, first thing, you are given the equation as lambda x square plus 13x plus 7 is equal to 0. Now it is given S is the set of possible S is the set of possible integral values. That means fractions are not allowed of lambda between the interval. That means lambda can have the value of minus 2, minus 1, 0, 1, 2, 3, 4, 5, and 6, for which the roots of this quadratic equation are rational numbers. What are the rational numbers? Which can be represented in the P upon Q form. That means, okay, we'll discuss. First of all, this is the given equation. If I'm saying that lambda can be only rational numbers, right? So that means for which roots, or sorry, roots, not lambda, for which roots of this quadratic equation can be rational numbers. If roots are the rational numbers, what is the root given by? It is given by minus b plus minus root of b square minus 4ac upon 2a. So if this is got to be the rational numbers, which means the discriminant should be discriminant should be perfect square. Then only the roots can be rational numbers. Okay, if it is not a perfect square, therefore the roots cannot be rational numbers because they are in the root. Okay, what is discriminant? That is given by b square minus 4 ac. What is b? It is 13. A lambda, c is 7. So this means you discriminant should be a perfect square, which gives you 13 square minus 4 into lambda into 7. That is equal to 169 minus 28 lambda. This should be perfect square. Now let's try, see the lambda can, we already discussed that lambda can have the values between these. So let's try for all the values. If I'm putting lambda is equal to minus 2, minus 1, 0, 1, 2, and so on. For lambda is equal to minus 2, you have 169 minus 28 lambda. This will be equal to 169 minus 28 into minus 2. This is equal to 169 plus this is equal to 225. This is a perfect square. So one value you got for lambda is, I'll write over here, minus 2. Let's move. Lambda is equal to minus 1. So 169 minus 28 lambda gives me 169 minus 28 minus 1. 169 plus 28, that is equal to 197. This is not a perfect square. 169 minus 28 lambda, 169 minus 28 into 0. This is 169. This is a perfect square because the root of it will give you 13. The root of this will give you 15. So the second value of lambda, possible value, is equal to 0. Next, lambda is equal to 1. This gives me 169 minus 28 into 1. This is 169 minus this, which is equal to 141, not a perfect square. Lambda is equal to 2. 169 minus 28 into 2. 169 minus 56. That is equal to 113. So again, not a perfect square. Lambda is equal to 3. You have 169 minus 28 into 3. 169 minus 84. This gives you 85. Next is lambda is equal to 4, 5, and 6. This gives you 169, 28 multiplied by 4, 169, 28 multiplied 5, 169, 28 multiplied 6. That's equal to 169 minus 112, that is 57, not a perfect square. 169 minus 140, 29, not a perfect square. 169 minus 168, that is equal to 1. This is a perfect square. So the third possible value for lambda over here is 6. You have to find out S was having all the integral values and S came out of lambda for which the roots are a rational number. So S came out to be 2, minus 2, 0, 6. You have to find out sum of elements of S. Required sum is minus 2 plus this, that is equal to 4. So we have option A as the answer. Hope you got that. Next, question number 12. Alpha is the maximum value of 1 minus 2x minus 5x squared. Beta is the minimum value of x squared minus 2x plus r. If 5 alpha x squared plus beta plus 6 is greater than 0, therefore all the real values of x and the interval in which r lies is. You are given here fx is equal to this, right? So this can be written as, I can write it as, I'll take 5 common, minus 5 common rather. This is x squared plus 2 by 5x minus 1 by 5. That is equal to minus 5 and x plus 1 by 5 square minus 1 by 5 minus 1 by 25. right? I have converted this into the perfect square, and I have subtracted 1 minus 1 upon 25 over here. So this will become minus 5x plus 1 upon 5 whole square plus 1 plus 1 by 5, which is equal to minus 5x plus 1 by 5 whole square plus 6 by 5. Now alpha is the maximum value of it. So maximum value will come when this is equal to 0. So that means alpha. See over here, fx is less than 6 by 5. That means the maximum value, that is alpha, is equal to 6 by 5. Now let's take the second one, that is gx. It is x square minus 2x minus r plus r. I can write it as perfect square again, x minus 1 whole square plus r minus 1. So that means gx is always greater than r plus 1, right? Because this is the positive value which is being added to r plus 1. So gx is always greater than r plus 1, and hence the minimum value, that is beta, is equal to r minus 1 in this case. Now the given expression to find was 5 alpha x square plus beta x plus 6. This gives me 6 x square, because see, this is all right, plus beta was r minus 1 into x plus 6. This gives me 6 x square plus r minus 1 into x plus 6. Therefore, the discriminant is less than 0. See in the question, for all the real values of x. So, discriminant is less than 0. Sorry, greater than 0. Discriminant is given by b square minus 4ac. That means r minus 1 whole square minus 4 into 6 is greater than 0. R minus 1 whole square is greater than, this is equal to 24 6 or 36 4s are 144, or that is equal to r minus 1 square is greater than 12. R minus 1 is greater than 12. So that means R, this is actually plus minus 12. So R minus 1 can be greater than 12, or R minus 1 can be greater than minus 12. This gives you R is greater than 13 and R is greater than minus 11, right? Question number 12, alpha is the maximum value of 1 minus 2x minus 5x squared. Beta is the minimum value of x squared minus 2x plus r. If 5 alpha x squared plus beta x plus 6 is greater than 0 for all real values of x, then the interval in which r lies is. So let this be the first function fx, and I'll say this as gx. Fx is given to you 1 minus 2x minus 5x squared. Let's take minus 5 common from here. You will have here x square plus 2 by 5 x minus 1 by 5, that is equal to minus 5 x plus 1 by 5 whole square minus 1 by 5 minus 1 by 25. See, I have added and subtracted 1 upon 25 to make this a perfect square. So this can be written as minus 5 into x plus 1 by 5 whole square plus 1 plus 1 by 5. This will give me minus 5x plus 1 by 5 whole square plus 6 by 5. So this whole expression is equal to this. See, therefore, fx is always less than equal to 6 minus 5, because this value will be, which is a perfect square, which this will be subtracted from here. So fx is always less than this value, 6 by 5, which means the maximum value for this fx, that is alpha, is always 6 by 5. Let's go to the second one, that was gx. It is equal to x square minus 2x plus r. Let's make the perfect square again. This can be made by x minus 1 whole square plus r minus 1. So here gx is always greater than r minus 1, because a perfect square is being added to r plus 1, right? Hence, minimum value that gx can have, minimum value gx, that is beta, is r plus 1. Correct? Now let's get to our expression. If this is greater than 0 for all real values of x, that was 5 alpha x square plus beta x plus 6. This is 5 into 6 by 5 into x square. Beta was r minus 1. So this is the expression. This gives you 6x square plus r minus 1 into x plus 6. Yeah. So now it's given for all real values of x. That means x can have the real values. X will have the real values only when discriminant is greater than 0. Correct? Discriminant is b square minus 4ac. This is greater than 0. So this is equal to r minus 1 square minus 12 square is greater than 0. A square minus b square. This is a plus b. A minus b. This is r plus 11. R minus 13 is greater than 0. So that means R will belong to minus 11 and 13. Okay, so we have option D as the answer. Hope you understood this question. Let's move to the next question, number 13. For the equation x raised to power 4 plus x cubed minus 4x squared plus x plus 1 is equal to 0, the ratio of the sum of square of all the roots to the product of the distinct roots is, let's factorize this equation first. X raised to power 4 plus x raised to power 3 minus 4x square plus x plus 1 is equal to 0. One factor is x minus 1. X is equal to 1 is a root over here. So x minus 1 is a factor. If x minus 1 is a factor, let's find out the remaining equation. X raised to power 4 plus x raised to power 3 minus 4x square plus x plus 1. So here is x minus 1. First, it will go with x cube. This will be x raised to power 4 minus x cube minus plus. You have 2x square minus 4x square plus x plus 1. Now plus 2x cube, 2x square. So 2x cube minus 2x square minus plus cancel. You have minus 2x square plus x plus 1. Again, I have minus 2x over here. Minus 2x square plus 2x plus minus. They will cancel. And I have minus x plus 1. So minus 1 over here. Minus x plus 1. This will give me a 0 plus minus. Okay, so here the second factor came out to be. So this can be written as x minus 1 into x raised to power 3 plus 2x square minus 2x minus 1. Again, x minus 1 is a factor. So on dividing this with x minus 1, you will get the quotient as x square plus 3x plus 1. So this is equal to x minus 1 into x minus 1. And this can be written as x minus 3 minus 3 plus root of 5 upon 2 multiply x minus 3 minus root of 5 upon 2. Let's discuss how we got these two terms. I'll solve it here. X square plus 3x plus 1. So the roots are given by minus b plus minus root of b square minus 4ac upon 2a. This is equal to minus 3 plus minus b square, which is 3 square, that is 9 minus 4 into 1 upon 2. This is equal to 3 plus minus root of 5 upon 2. So therefore, I got these two as the factors of this equation, right? So x minus 1 into x minus 1 into this, these are the equation roots. Clear? Therefore, what are the roots of the given equation? That is given equation are 1, 1, 3, minus 3 plus root 5 upon 2, and yeah, this is minus 3 minus root 5 upon 2. So these are the four roots of the given equation. It is given in the question this ratio of sum of square of all the roots, sum of square of all the roots to the product of the distinct roots is. So the required ratio, now required ratio, pay attention, you have to find out the sum of the square. So that is equal to 1 square plus 1 square plus this square plus this square plus minus 3 plus root 5 upon 2 square plus minus 3 minus root 5 upon 2 square divided by, divided by the product of the distinct roots. One, there is only these two roots, they are repeating themselves. So rest are the distinct roots. So 1 into minus 3 plus root 5 upon 2 into minus 3 minus root 5 upon 2. Now let's solve it. That is 2 plus, upon here you will have a squared plus b squared. This is going to give you 9 plus 5 minus 6 root 5 upon 4 plus 9 plus 5, that's plus 6 root 5 upon 4 multiplied by 1 multiply. I'll take 4 over here. And this is a plus b into a minus b, which is equal to a square minus b square. So minus 5 square minus 3 square. Yeah. Okay. Into minus 1. I have taken the minus common from here. Got this thing? So that is equal to, let's solve it further. This is equal to, I'm taking the LCM. This is 8 plus 14 minus 6 root 5 plus 14 plus 6 root 5 whole divided by 4. And this is divided by, okay, I'll write it here, multiplied by 1 upon, this is 5 minus 9, that is going to give you 9 minus 5 upon 4. Okay, this is equal to, they will cancel out, and 28 plus 8, that is equal to 36 upon 4, multiply by 1 upon 4, this will cancel. So you have 9 as the answer. Okay, you had to find out the ratio. So the ratio is, this is equal to 9 by 1. So the ratio is equal to 9:1, which is option C. Hope you got that. Next is question number 14. If alpha 1, beta 1, gamma 1, and delta 1 are the roots of this equation, and alpha 2, gamma 2. So these are the roots of this equation such that 0 is less than alpha 1, is less than beta 1, gamma 1 less than this, and this holds true, comma, alpha 1 minus delta 1 is equal to 2, beta 1 minus gamma 2 is equal, these are equal. These are equal and these are equal, then A plus B plus C plus D plus E is equal to. So the question is not tough. Actually, a lot of variables are involved. That is giving it a weird look. Okay, let's start with the question. Now you are given that these four are the roots of this equation. Correct? And here it is raised to power 4. So this is a 4-degree polynomial. Alpha 1, beta 1, gamma 1 and beta 1 are the roots of a x raised to power 4, b x cube, c x square, dx plus e is equal to 0. And alpha 2, beta 2, gamma 2, delta, sorry, here was delta 1, delta 2 are the roots of the equation e x raised to power 4, dx cube, cx square, bx plus a is equal to 0. So from both of them, clearly alpha 1, beta 1, gamma 1 and delta 1, they are the reciprocals of roots of ex raised to power 4 plus dx cube, cx square plus bx plus a is equal to 0. So also one more thing that's given is delta 1 is greater than gamma 1 is greater than beta 1 is greater than alpha 1 is greater than 0. Also delta 2 is greater than gamma 2 is greater than gamma 2 is greater than beta 2 is greater than alpha 2 is greater than 0. Therefore, delta 1 and alpha 2 are reciprocals. Similarly, gamma 1 and beta 2 are reciprocals, and gamma 2 and beta 1 are reciprocals, alpha 1 and delta 2 are reciprocals. If these are so, therefore, alpha 1 into delta 1 is equal to 1, beta 1 into gamma 2 is equal to 1, beta 2 into gamma 1 is equal to 1, also alpha 2 into delta 1 is equal to 1. Also, you are given that alpha 1 minus delta 2 is equal to 2. In the question, it's given that this is equal to 2. Therefore, alpha 1 minus 1 upon alpha 1 is equal to 2, which gives you alpha 1 square minus 2 alpha 1 minus 1 is equal to 0. Also, you are given that delta 1 minus alpha 2 is equal to 4, which is delta 1 minus 1 upon delta 1 is equal to 4. That is delta 1 square minus 4 delta 1 minus 1 is equal to 0. Therefore, alpha 1 and delta 1 are roots of ax raised to power 4, bx cube, cx square plus dx plus e is equal to 0. Therefore, x squared minus 2x minus 1, x squared minus 4x minus 1 is equal to ax raised to power 4 plus bx cube plus cx square plus dx plus e. If I put x is equal to 1, you have it 1 minus 2 minus 1 into 1 minus 4 minus 1 is equal to a plus b plus c plus d plus e. So that means this is equal to a plus b plus c plus d plus e is equal to minus 2 into minus 2, that is equal to minus 4, sorry, over here. Yeah, so that is equal to 8. We have option D as the correct answer. Hope you got that. Let's move to the next question, number 15. It says the total number of 3-digit and 5-digit integers which can be formed by using these digits, but using each of them not more than once in each number is. So first, if I consider the 3-digit numbers. So the 3-digit numbers which can be formed by using 0, 1, 2, 3, 4, 5 is 1, 2, 3. See, I can't. Okay, fine. So, how many digits are there which are possible at this place? I can't use a zero at this place because then it will be a two-digit number. So, the possible digits which can be filled in this place is 5. And then I'll be left with 5 digits. So, 5. And then I'll be left with 4 digits. So, 4. So, the total number of ways of making 3-digit numbers is 5 into 5 into 4, which is 100. Now let's go for 4-digit number. So 1, 2, 3, 4. Again, I can't have a 0 over here. 0 is not possible. That means 5 ways in which this place can be filled. Then I'll be left with 5 digits again. So 5 ways again, then 4, and then a 3. So the number of ways of making 4-digit numbers is 5 into 5 into 4 into 3. That is equal to 300. 5 into 5 into 4 into 3. Sorry, I had to make a 5-digit number over here. So sorry for this. So 5-digit number, that means this can be filled in 2 places. So this is gonna give me into 2, that is equal to 600. Okay, now the total number of required numbers is equal to 700. Okay, we have option C as the answer. Hope you understood this. Next is question number 16. At an election, a voter may vote for any number of candidates not exceeding the number to be elected. If 4 candidates are to be elected out of 12 candidates, 12 contested in the election, and voter votes for at least one candidate, then the number of ways in which a voter can vote is. So the number of ways of selection, here you have 4 candidates. So the number of ways of selection are 12C1 plus 12C2, 12C3, and 12C4. 12C1, this is 12 only, and 12C2 is 12 into 11 upon 2 divided by 10 factorial. Actually, this is into 10 factorial. Into 10 factorial. So this will cancel, and plus 12 into 11 into 10 upon 3 into 2 into 9 factorial plus 12 into 11 into 10 into 9 upon 4 into 3 into 2 into 1 into 8 factorial. They will cancel, and you will have 12 plus 66 plus 220 plus this is plus 495. A total will give you 793. So you have option A as the answer. Hope you understood this. Then let's move to the next question. Question number 17. Let x belong to real numbers be so small that the powers of x beyond 2 are insignificant and negligibly small. For such x, if this is approximated by this expression, then what is the value of a plus b plus c? So basically, you have to find out the value for this expression, but we have the x is so small that even the very high powers, they can be easily neglected. So the very first term in this is 1 minus x raised to power 3. This can be written as 1 minus 3x plus 3x square if I'm neglecting higher terms, because the power of x will be increasing and x will be decreasing. neglecting higher terms. Next, 2 plus x raised to power 6. This is equal to 6c0, 2 raised to power 6, x raised to power 0, 6c1, 2 raised to power 1, 2 raised to power 5, x raised to power 1, 6c2, 2 raised to power 2, x raised to power 2, and so on. Again, I'm neglecting high terms in this case as well. So this is gonna give me, that's 1 into 64 plus 6 into 32 plus that's 6c2, this is 6 into 5 upon 2. So that is equal to 30 into 2 raised to power 4 is, okay, that's 240 x square. Correct. Now 1 minus x cube plus in multiply 2 plus x raised to power 6 is 1 minus 3x plus 3x square multiply 64 plus 192 x plus 240 x square. This is gonna give me 64 plus 192 x 240 x square minus this minus 576 x square plus 192 x square. Again, I'm neglecting higher terms because x will be decreasing there. So on solving, this will give you minus 144 x square plus 64. Let's compare it with the given equation, that is a plus bx plus cx square. So this is equal to a plus bx plus cx square. Here a is equal to 64, b is 0, c is minus 144. You have to find out a plus b plus c, that is equal to 64 plus 0 minus 144, which is equal to minus 80. That means you have option A as the correct answer. Hope you got that. Let's move to the next question then. Question number 18. For x lying between 0 and 1, the expansion of this is what? So I'll start with this given expression, 1 plus 1 upon x raised to power 1 by 2. This is equal to, let's expand it. So this is equal to 1 plus 1 by 2 into 1 by x plus 1 by 2. Okay. 1 by 2 into 1 by 2 minus 1 divided by 2 factorial into 1 upon x square plus 1 by 2, 1 by 2 minus 1, 1 by 2 minus 2 whole divided by 3 factorial into 1 upon x whole raised to power 3. Again, next one, 1 by 2, 1 by 2 minus 1, 1 by 2 minus 2, 1 by 2 minus 3 whole divided by 4 factorial 1 by x raised to power 4. Now, see, this will go on. This will keep on going. So you can perfectly write this as 1 plus 1 upon 2x minus 1 upon 2 factorial into 1 upon 2x square, 1 into 3 factorial, 1 upon 2x raised to 1 upon 2x whole raised to power 3. And here will be minus 1 plus 3 into 5 upon 4 factorial, 1 upon 2x whole raised to power 4, so on till infinity. So looking at that, this is matching with, yeah, this is matching with option B. Sorry, this is matching with option A. So option A is the correct answer to the question. Hope you understood this. Let's move to the next question. Question number 19. If this expression is equal to this plus this, then b plus 2, d plus f plus a minus c into a is. Okay. Let's write on the expression first. You have 4x square 5x raised to power 4 plus 7 whole divided by x square plus 1 x raised to power 4 plus x square plus 1 is equal to ax plus b x square plus 1 plus cx cube dx square ex plus f whole divided by x raised to power 4 x raised to power 2 plus 1. This gives you, I'm taking the LCM on the RHS and then I'll be cancelling all the denominators. So 4x square plus 5x raised to power 4 plus 7 is equal to ax plus b, x raised to power 4, x raised to power 2 plus 1 plus cx cube dx square ex plus f into x squared plus 1. This gives me 5x raised to power 4 plus 4x square plus 7 is equal to ax raised to power 5, ax cube, ax plus bx raised to power 4 plus bx square plus b cx raised to power 5 cx cube dx 4 dx square ex3 plus ex fx square plus f. Okay, so 5x raised to power 4 plus 4x square plus 7 is equal to, I'll take the common now, a plus c x raised to power 4, b plus d x raised, sorry, a plus c x raised to power 5, b plus d x raised to power 4 plus a plus c plus e x raised to power 3 plus b plus d plus f x raised to power 2a plus e x b plus f, right? So now on comparing them, you get a plus c is equal to 0, b plus d is equal to 5, a plus c plus e is equal to 0, and I'll write here b plus d plus f is equal to 4, a plus e is equal to 0, b plus f is equal to 7. So on solving them, we will get that a is equal to c is equal to e is equal to 0, and you will get the value of b as 8 and d as minus 3, b as minus d as minus 3, f will be minus 1. Therefore, you have to find out b plus 2 d plus e plus f minus c into a. B was equal to 8 plus 2, d is minus 3, e is 0, f is minus 1. Minus c is equal to 0 again, and a is 0. So this is equal to 8 plus 2 into minus 4, that is 0. So you have option A as the answer. Hope you got that. Let's move to the next question. Question number 20, sine raised to power 4 pi by 8 plus cos raised to power 4 3 pi by 8 minus sine raised to power 4 3 pi by 8 plus sine raised to power 4 5 pi by 8 plus all of this is equal to. Okay, so I'll start from here. The given equation is this. So this is equal to sine raised to power 4 pi by 8 plus cos raised to power 4 3 pi by 8 minus sine raised to power 4 3 pi by 8 plus sine raised to power 4. So now 5 pi by 8 can be written as pi minus 3 pi by 8. And I will write 7 pi by 8 for the cos as such, minus sine raised to power 4 pi minus pi by 8. This is equal to sine raised to power 4 pi by 8 cos raised to power 4 3 pi by 8 minus sine raised to power 4 3 pi by 8 plus sine raised to power 4 3 pi by 8, because pi for pi minus something, it is sign will be remain to sign only and it will rise in the second quadrant, so it will be positive, plus cos raised to power 7 pi by 8, and this will be minus sine raised to power 4 pi by 8. Now let's do the cancellations. These two will cancel and this will cancel with the, sorry, here was 8, right? So these two will also cancel. And you will be left with cos raised to power 4, 3 pi by 8 plus cos raised to power 4, 7 pi by 8. These two terms I'll be left with. So this is equal to cos 3 pi by 8 plus cos raised to power 5, cos raised to power 4 pi minus pi by 8. That is equal to cos raised to power 4 3 pi by 8 plus minus cos pi by 8 raised to power 4. That is cos raised to power 4 3 pi by 8 plus cos raised to power 4 pi by 8. Now, this can be written as 1 plus cos 3 pi by 4 whole divided by 2 plus and square over here. Like this. 1 plus, see, I'm taking this as square and square and square and square. Okay. 1 plus cos pi by 4 upon 2 whole square. So that is equal to, I'll take 1 by 2 square common. That is 1 by 2 will be taken outside. And cos 3 by 4 is 1 by root 2 square plus, wait, square plus 1 plus 1 by root 2 whole square. So that's equal to 1 by 4. I'll open the squares now. A square plus b square minus 2 this plus a square plus b square plus this. So you have 1 by 4, 3. That's 3 by 4. Option D is the correct answer. Hope you got that. Next is question number 21. Cosecant inverse, this whole expression is equal to. So I have tan terms, cos alpha by 2, cot alpha by 2, secant alpha by 2, secant 11 alpha by 2. Let's start with the question now. You are given, let's write down cosecant inverse tan square alpha minus pi upon 4 minus 1 whole divided by tangent square alpha minus pi upon 4 plus 1 plus cos alpha by 2 into cot 5 alpha secant 11 alpha upon 2. Now that's equal to cosecant inverse minus cos 2 alpha minus pi upon 4 plus cos alpha by 2 into cot 5 alpha into secant 11 alpha by 2, right? That's equal to cosecant inverse minus sine alpha by 2 plus cos alpha into cos 5 alpha upon 2 into alpha into sin alpha. See, I've opened the cot alpha, sin, cos, it will come over here. Okay. Yeah. Sorry, this 2, give me a minute. Okay, so this is cos alpha by 2 into question number 21, cosecant inverse tan square alpha minus pi upon 4 minus 1 upon tan square alpha minus pi upon 4 plus 1 plus cos alpha by 2 into cot 5 alpha into secant alpha by 2 is equal to. See, look at this one. This is the formula for, I'll just discuss. So this given expression, I'll start from here only. This is the formula for, this is cosecant inverse. Now this is the formula for minus cos 2 alpha minus pi upon 4. Rest will remain same, cos alpha by 2 cot 5 alpha secant 11 alpha upon 2. So this is cot 2 something. You can write it as cosecant inverse. So cos 2, this is minus cos. This can be written as pi by 2 minus 2 alpha, right? Sorry, alpha by 2, because 4 will be cancelled actually. Okay, so I can write it like this, minus inside that will be generated cos of, remember one thing, cos of minus x is equal to cos x. So minus sign inside will be adjusted. I'll be left with cos alpha by 2 into cot. I'll change cos, this cos 5 alpha upon sin 5 alpha into secant 11 alpha upon 2. That is equal to cosec inverse. Now this will be changed into sin alpha by 2 because pi by 2, the cos pi by 2 minus something, it will be changed into sin alpha by 2 plus cos alpha by 2 into cos 5 alpha upon sin 5 alpha secant 11 alpha upon 2. So let's do the cross multiplication, so LCM thing now. Cosecant inverse sin 5 alpha sin alpha by 2 minus plus cos 5 alpha into cos alpha by 2 whole divided by sin 5 alpha into secant 11 alpha upon 2. Now that's equal to cosecant inverse. This is the formula for cos A plus B. This gives you cos 5 alpha plus alpha upon 2 whole divided by sin 5 alpha into this. So that's equal to cosecant inverse. This is equal to cosecant 5 alpha into cos 11 alpha upon 2 into secant 11 alpha upon 2. They will cancel and you will have 5 alpha as the answer. That means option B is the correct answer. Hope you understood this. Let's move to the next question, number 22. Assertion A. This is the assertion and reason question. Assertion A says if A is 15 and degree B is 17, C is 13, then cot 12, 2A plus cot 2B plus cot 2C is equal to cot 2A into cot 2B into cot 2C. Okay. Then the second one, the reason is in a triangle PQR, tan P by 2, tan Q by 2 plus this is equal to 1. Fine. I'll start with the reason in the question. So the reason in the given question, that is this one, says, first of all, there's a triangle PQR. That means angle P plus Q plus R is equal to 180 degree. P by 2, Q by 2, R by 2 is equal to 90 degree, or P by 2 plus Q by 2 is equal to 90 minus r by 2. Let's take tangent on both the sides. You have tangent p by 2 plus q by 2 is equal to tangent 90 minus r by 2. So this is tangent a plus b formula. This is tangent of p by 2 plus tangent of q by 2 whole divided by 1 minus this is equal to, now tan 90 minus something, it will be changed into cot r by 2. This gives you tangent p by 2 plus tangent q by 2 into cot will be taken on the other side. Tangent r by 2 is equal to 1 minus tangent of p by 2 into tangent of q by 2. That is tangent p by 2, tangent to tangent r by 2 plus tangent q by 2 into tangent r by 2 plus tangent p by 2 tangent q by 2, that's equal to 1. So the reason is true. Look at this one. The reason is absolutely, this one is true. Now let's go with the assertion. See, assertion says you A is 15, B is 17 and C is 13. If I see the sum of all of them, that is equal to 45. Let's multiply them with 2. You have 90, right? Also, you see one thing, P by 2 is equal to 2A. Let's say Q by 2 is equal to 2B. And yeah. And R by 2 is equal to 2C. See, how does this thing happen? Look at this one. P by 2 plus Q by 2 plus R by 2, that was equal to 90. That means, and 2A plus 2B plus 2C is also equal to 90, which means 2A is equal to P by 2, 2B is equal to Q by 2, and 2C is equal to R by 2. Now I'll use the same thing, the same reason. That means I'm using the reason over here. So tangent of 2A into tangent of 2B plus tangent of 2B into tangent of 2C, tangent to C, tangent to A is equal to 1. I'm converting them into cotangent. So that means 1 upon cotangent to A, cotangent to B, 1 upon cotangent to B, to C, to C, and cotangent of 2A is equal to 1. Let's take the LCM. So cot 2C plus cot 2A, cot 2B is equal to, I'm doing the cross multiplication, cot 2A, cot 2B, and cot 2C. So simply you have cot 2A plus cot 2B is equal to cot 2A, 2B, and 2C. So that means assertion is also true. This is also true, which means both are correct. Assertion and reason both are correct, and reason is a correct explanation for A. We just showed, because in the assertion I have used, in solving the assertion, I have used this reason. Correct? So that means option A is correct answer. Hope you understood this question. Let's move to the next question, number 23. The solution set of the trigonometric equation tangent theta plus 5 cot theta is equal to secant theta is which of these following options? So I'll start here. We have this equation, tangent theta plus 5 cot theta is equal to secant theta. Tangent can be written as sine upon cos plus 5 cos upon sine is equal to 1 upon cos theta. You know, Here sine theta and cos theta, neither of them can be equal to 0. Let's take the LCM. You have sine square theta plus 5 cos square theta is equal to sine theta into cos theta upon cos theta. So you will be left with here, you can say this as sine theta square theta plus cos square. I'll be changing that into sine square. This is equal to sine theta. So sine square theta plus 5 minus 5 sine square theta is equal to sine theta. Okay. You can write it as 4 sine square theta plus sine theta minus 5 is equal to 0. Now, this is a quadratic equation in sine theta. So, the two factors you will get as minus 4 sine theta plus 5 and sine theta minus 1 is equal to 0, which gives you sine theta is equal to 1. Either sine theta is equal to 1 or sine theta is equal to minus 5 by 4. Okay, so I'll take the value sine theta is equal to 1 because, sine theta lies between 0 and 1. So, therefore, theta belongs to null. See, over here, there was one thing, sine theta cannot be equal to 1 because sine theta is equal to 1. Question number 23, the solution set of the trigonometric equation, this is the trigonometric equation. Let's split it. You can write it as sine theta upon cos theta plus 5 cos theta upon sine theta is equal to 1 upon cos theta. Here you have conditions that sine theta cannot be equal to cos theta cannot be equal to 0. Sine theta and cos theta. See, actually sine theta cannot be equal to 0 and cos theta cannot be equal to 0. Let's take the LCM. You will have sine square theta plus 5 cos square theta is equal to sine theta into cos theta upon cos theta. So here you have sine square theta and cos theta can be written as 1 minus sine square theta, that's equal to sine theta. This will give you sine square theta plus 5 minus this is equal to sine theta. So now this will form a quadratic equation. How? This is equal to 4 sine square theta plus sine theta minus 5 is equal to 0. See, remember the conditions. Cos theta cannot be equal to 0. Sine theta cannot be equal to 0 as per the given equation. So this is a quadratic equation. So the two factors on solving will be 4 sine theta plus 5 and sine theta minus 1 is equal to 0. Two possible values are sine theta is equal to 1 or sine theta is equal to minus 5 by 4. Sine theta lies between minus 1 and 1. So this is not possible, right? That means sine theta, if I'm taking sine theta is equal to 1, this is also not possible. Why? Because if we consider the starting equation, which was tangent of theta plus 5 cot theta is equal to secant theta. If I put sine theta is equal to 1, this will evaluate to give me cos theta is equal to 0, which is not true. In the starting only, this equation is possible only if sine theta and cos theta were not equal to 0. But if I put sine theta is equal to 1, I will get cos theta will be equal to 0. So that means here theta belongs to null. There is no such possible value for theta. So the solution set of this trigonometric equation is a null. Option D. Hope you got that. Next is question number 24. If tangent inverse 1 by 5 plus 1 by 2 secant inverse x plus tangent inverse 1 by 8 is pi by 8, then what is the value of what is the value of x square? Tangent inverse 1 by 5 plus half secant inverse x tangent inverse 1 by 8 is equal to pi by 8. This gives you tangent inverse 1 by 5, tangent inverse 1 by 8 plus half secant inverse x is equal to pi by 8. That's see tangent inverse A plus tangent inverse B. The formula is tangent inverse 1 plus 5 upon 1 plus 8 divided by 1 minus this into half secant inverse x, that's equal to pi by 8. This gives you tangent inverse. On solving, this will be 13 upon 39 plus half secant inverse x is equal to pi by 8, or that's equal to, I'm taking LCM also. So 2 tangent inverse 1 by 3 plus secant inverse x is equal to pi by 4. That is tangent inverse. See, 2 tangent inverse 1 by 3 plus secant square x. This is 2 tangent inverse 1 by 3. I can write it as tangent inverse 2 by 3 upon 1 minus 1 by 9. That's equal to pi by 4. This will give you tangent inverse 3 by 4 secant inverse x is equal to pi by 4. So that's tangent inverse 3 by 4. Secant inverse will be tangent inverse root of x square minus 1 is equal to pi by 4. See, that's now tangent inverse A plus B. So this is equal to tangent inverse 3 by 4 plus root of x square minus 1 whole divided by 1 minus 3 by 4 into this is equal to pi by 4. So that is equal to 3 by 4 plus, this will be 3 plus 4 x square minus 1 upon 4 minus 3 root x square minus 1. Tan pi by 4, that's equal to 1. So 3 plus 4 root x square minus 1 is equal to 4, 3 root x square minus 1. This will give me 7 root x square minus 1 is equal to 1, or that's equal to 1 by 7, which will give me x square minus 1 is equal to 1 upon 49, or x square is equal to 50 upon 49. So this is the answer to the question. You have to find out the value of x square. 50 upon 49 is option B. Hope you understood this question. Let's move to the next question then. Question number 25, students. Before starting this question is a quick reminder to visit our website www.examsnet.com. Here you will practice similar type of multiple entrance exam question papers. You have the solutions and PDFs available over there. You can also download our app. The link is available in the description box. So here we go. Question number 25. We have an assertion which says cosec inverse 3 is equal to log 1 plus root 10 upon 3. The reason for the same is e raised to power here is cosec h inverse x is a root of this quadratic equation. So let's go with this. You have the quadratic equation xp square minus 2p minus x is equal to 0. The two roots will be given by p is equal to 2 plus minus 4 plus 4x square upon 2x. I'll divide the numerator and the denominator by 2. So you have 1 plus minus root of 1 plus x square upon x. So the two roots come out to be 1 plus root 1 plus x square upon x and 1 minus root 1 plus x square upon x. These are the two roots. And this can also be written in the form of e raised to power natural log 1 plus this and e raised to power natural log 1 minus this. Since you have cosec h inverse x is equal to log of this, therefore e raised to power cosec h inverse x is a solution of the given equation. So now cosec h inverse 3 is equal to log 1 plus root of 1 plus 3 square upon 3, that is equal to log of 1 plus root 10 upon 3. So you have the assertion as true and the reason also true. That means assertion is true and reason is also true, and reason is the correct explanation of the assertion because we have used this reason to solve the assertion. Hence, option A is the correct answer. Hope you got that. Next is question number 26. In a triangle ABC, A angle is 3. Okay. Actually, 3. 3. Fine. A angle is 3. B. Okay, fine. Sorry. A angle is thrice angle B, and CA is 9. BC is 16. Then you have to find out the length of AB. Let's draw the triangle. So here is the triangle ABC. This is A, B, and C. So this is the triangle. And it's given angle A is equal to thrice of angle B. If I'm assuming the angle B to be theta, that means A is equal to 3 theta. And of course, angle C is 180 minus 4 theta then. And you are given CA is 9. This is 9 and BC is 16. These are the things which are given. So in this triangle, by using the sine rule, you know AB upon sine C is equal to BC upon sine A is equal to AC upon sine B. Correct. Okay, so you can write it as AB upon sine 180 minus 4 theta is equal to 16 upon sine 3 theta is equal to 9 upon sine theta, which can be written as AB upon sine 4 theta is equal to 16 upon sine 3 theta is equal to 9 upon sine theta. Now, 16 upon sine 3 theta is equal to this, which gives you 16 sine theta is equal to 9 sine 3 theta, or 16 sine theta is sine 3 theta can be written as 3 sine theta minus 4 sine cube theta. So 16 is equal to 27 minus 36 sine square theta, which is 36 sine square theta is equal to, that's going to give you 11. Okay, so that means sine square sine theta is equal to root of 11 upon 6. Using sine square theta plus cos square theta is equal to 1, you will find out that cos theta is equal to 5 upon 6. Now, sine 4 theta is equal to 4 sine theta into cos theta into 1 minus 2 sine square theta. I hope you got this thing, how I have got this. So sine 4 theta can be written as 2 sine 2 theta cos 2 theta, and 2 sine 2 theta can be written as 4 sine theta cos theta, and cos theta, sorry, here is cos 2 theta, and cos 2 theta can be written as 1 minus 2 sine square theta. Okay, so now this is equal to, I'll fill in all the values, 4 into root of 11 upon 6 into 5 upon 6 into 1 minus 2 into 11 upon 36, which on solving will give you 35 root 11 upon 162. So again, okay, we got this value sine 4 theta. Now I'll get back to we were having AB upon sine 4 theta is equal to 9 upon sine theta. You had from here, from equation 1, from equation 1. So here you have AB as 9 sine 4 theta upon sine theta, that is equal to 9 into 35 upon root of 11. Sorry, 9 into, sorry, this is 9 into 35 into root 11 whole divided by 162 multiplied by 6 upon root in 11. So this will cancel out, and you will have on solving 35 upon 3 as the answer. So 35 upon 3, that is option D, is the correct answer. Hope you understood this. Let's move to the next question. Question number 27. In triangle ABC, 1 plus cos C upon R1 plus R2 plus 1 upon 1 plus cos A upon R2 plus R3 plus 1 plus cos B upon R1 plus R3 is equal to. Okay, we know one thing, that R1 plus R2 is given by 4R sine A by 2 cos B by 2 cos C by 2 plus sine B by 2 cos A by 2 and cos C by 2. I'll take cos C by 2 common. You will have sine A by 2 cos B by 2 plus sine B by 2 cos A by 2. So that is equal to 4R cos C by 2. So this is sine A cos B plus cos A sine B. That is the formula for sine A plus B, which gives you sine A plus B upon 2. Now that is equal to 4R cos C by 2. You can write it as sine pi by 2 minus C by 2. That gives you 4R cos C by 2 into cos C by 2, or 4R cos square C by 2. Now this is 2R into 2 cos square C by 2, or that's equal to 2R1 plus cos C. So 1 plus cos C upon R1 plus R2 is equal to 1 upon 2R. Similarly, 1 plus cos A upon R2 plus R3 is equal to 1 by 2R, and 1 plus cos B upon R1 plus R3 is equal to 1 upon 2R. So let's add all of them. When you will add them, you will get 1 plus cos C upon R1 plus R2 plus 1 plus cos A upon R2 plus R3, 1 plus cos B upon R1 plus R3. This whole is equal to 3 upon 2R. So that means we have option C as the answer. Hope you understood this. Let's move to the next question. Question number 28. In a triangle ABC, if cos A cos B plus sin A sin B sin C is equal to 1, you have to find the ratio of A is to B is to C. You are given cos A cos B plus, I'll start from here only. I'm considering this as the first line, so I'm solving it further now. So cos A cos B, now adding and subtracting sin A sin B minus sin A sin B plus sin A sin B sin C is equal to 1. Now this is the formula for cos A minus B. Cos A cos B plus sin A sin B is the formula for cos A minus B, minus, I'll take sin A sin B common, and here will be 1 minus sin C. This is equal to 1. Now 1 minus cos A cos B, I'll take 1 over here, and you will have 1 minus I'll take everything on the right hand side. 1 minus cos A minus B plus sine A sine B brackets 1 minus sine C is equal to 0. 1 minus cos A minus B is 2 sine square A minus B upon 2 plus sine A sine B 1 minus sine C is equal to 0. Now you know sine A is greater than equal to 0, right? And that's also equal to sine B and sine C. So they lie between 0 and 1. Therefore, sine A minus B upon 2 is equal to 0, and this, both the things, they will be equal to 0. Sine B A, sine B 1 minus sine C is equal to 0. Fine. So this means this is possible only in the case this is equal to sine 0. This means sine A minus B upon 2 is equal to 0, or A is equal to B, or here from here 1 minus sine C is equal to 0, which gives you sine C is equal to 1, right? If A is equal to B, that means in this case C will be 90. So here A is equal to B, that is equal to 45, and C will be equal to 90, right? Okay. Next, by the sine rule, you have A upon sine A is equal to B upon sine B is equal to C upon sine C. That means A upon sine 45 degree is equal to B upon sine 45 degree, C upon sine 90 degree. So A is to B, this is equal to A upon this, B upon this, C upon 1. So A is to B is to C is, that is equal to 1 is to 1 is to root 2. That's it. So you have an answer as option A. Hope you understood this. Let's move to the next question, number 29. Let OA vector be A, OB be B vector. These are two non-collinear vectors. OP is given by this, OQ is given by this, A dash O is equal to O, over OA vector, and B dash O vector is equal to OB vector. If x1, x2, y1, y2, these are given values, you have to find out which of the following is true. You are given that the vector OA is A, and I'll just write normally. OA is equal to A and OB vector is given by B. OP is given to you as this. I'm filling the values from x1 and y1 from here as such. So OP is given by minus 3 by 4A plus 7 by 4B, which is equal to, I'm taking 4 common, 7B minus 3A. And I can write it as 7B minus 3A upon 7 minus 3. That's equal to OP, right? Yeah. So now if we see this OP divides AB. See, A is this vector, B is this vector. Externally, see 7 minus 3. So it is dividing it externally in the ratio 7 is to 3. Right? OP vector is dividing the AB vector in the ratio 7 is to 3 externally. Also, it's given that A dash O is equal to OA. A dash O is equal to OA vector, and that's equal to A. That means OA dash vector is equal to minus A. Also, B dash O is equal to OB. This is equal to B given, which means OB dash is equal to minus B. If I look at the vectors, if I make them, if this is vector A, which is given by this, then this is A dash, which is given by minus A. And if I take this one as B, so this is B dash, this is B, and this is minus B vector. Right? Now, AB vector is being divided by some P. P is 7B minus 3A upon 4. So P is dividing AB vector external in the ratio 7:3. If I look at this one, okay, one more thing. I have to talk about OQ also because Q is also being talked about here. OQ vector will be given by 1 by 3A plus 5 by 3B. How is that? If I fill in the values from here, 1 by 3A plus 5 by 3B, which gives you OQ as 3A plus 5B or A plus 5B upon 7 minus 4. So similarly, it's dividing OQ, or Q is dividing AB externally in the ratio 7:4. So if I look at this one, then clearly the P will OP, since OP is dividing over here. OP is dividing AB externally in the ratio 7:3. So it will lie outside A dash, sorry, inside A dash OB, and Q lies outside the triangle AOP, right? That gives you option A to be the correct answer. Hope you got that. Let's move to the next question. Question number 29, let OA be the vector this and OB be this vector. These two non-collinear vectors such that OP is given by this, OQ is given by this, and A dash O vector is equal to OA vector, and B dash O vector is equal to OB vector. If x1 is this, x2, y1, y2, these are the given values, then which of the following is true? So in the question, first thing I have that OA is A vector and OB vector is given by B. Also, OP is equal to x1A plus y1B. Also, OQ is x2A plus y2B, which gives you, I'll put in the values of x1, y1. So OP will be equal to minus 3 by 4A plus 7 by 4B, and OQ is equal to 1 by 3A plus 5 by 3P. OP from here, this is equal to 7B minus 3A upon 4, or 7B minus 3A upon 7 minus 3. Therefore, OP divides AB externally in the ratio of 7:3. Right? There also one more thing, you are given that A dash O is equal to OA, and that's equal to A. Simply OA dash will be equal to minus A. That is, they are in the opposite direction, somewhere like this. If I draw them on the coordinate plane. So if I'm taking this as this I'm drawing. So this is OA. If I'm taking this as A, this is equal to minus A. So this is equal to minus A, and this is A dash. Similarly, if I'm taking this as B, this is B dash and negative of B, right? So OB dash, similarly, OB dash is equal to minus of B. The magnitude is minus B. Okay. Now, the point P is dividing AB in the ratio 7:3. So point P is lying somewhere over here. If I'm drawing a triangle, so looking at that, P clearly lies inside triangle A dash OB, and Q lies outside the triangle AOB, which makes option A to be the correct answer. Hope you understood this. Next is question number 30. The position vector of a point P is given by this. A and B are two vectors which determine the plane pi. Equation of the line through P normal to B and lying on the plane pi is. So here you're given that P is having the position vector as 2i plus 3j plus 3k. Equation of the plane is given by r minus 2i plus j plus 3k dot a cross b is equal to 0. Therefore, normal of plane is this. So, equation of line through P 2i plus j plus 3k and normal to B and lying on the plane pi is, and lying on the plane pi is given by r is equal to 2i plus j plus 3k plus lambda a cross b cross b. Uh, yeah. Mm, yeah. Okay. So here r is equal to 2i plus j plus 3k plus lambda into b dot a b minus b dot b dot a. And see, if I calculate b dot a, you will get it as, I'll write plus lambda. So you will, here b is given by this vector and a is given by this vector. So 1 minus 1, 0 plus 1 and 2 multiplied by minus 2, this is 4. So this is going to give me 5. B minus a, this will be negative 5. B is I plus j plus 2k minus similarly b dot b. So you will multiply b dot b, you will get 1 plus 1 plus 2 into 2, 4, that is equal to 6. So this is minus 6. A vector is minus I minus 2k. That gives you r is equal to 2i plus j plus 3k plus lambda into minus 5i plus 6i. This is going to give you, yeah, this is minus I cap plus 5j. And this is question number 30. The position vector of the point P is this, and A and B are the two vectors which determine the plane pi. Equation of the line through P, which is normal to B and lying on the plane pi, is. So here you have position vector of P is given by 2i plus j plus 3k. And according to this equation of plane is r minus 2i plus j plus 3k dot a cross b is equal to 0. So normal of the plane is a cross b. Now required equation of the line through P, normal to B and lying on plane pi is r is equal to 2i plus j plus 3k plus lambda a cross b cross b. So this is equal to 2i plus j plus 3k plus lambda. Let's open this. This is a dot b minus b dot a. So that's equal to 2I plus j plus 3k plus lambda a dot b is that's equal to -1 plus 0 minus 4, that is -5. So -5, and the b vector was equal to I plus j plus 2k. And similarly, you will calculate b vector. B vector is b is this vector. So b is 1 plus 2 square, that is 4, and that's equal to 6. So -6 into -I minus 2k, that is equal to 2I plus j plus 3k plus lambda into that's I, then minus 5j plus 2k. So, but there is no such option, but I have minus I plus 5j minus 2k. So this can be converted. This can be written as 2I plus j plus 3k minus lambda I minus 5 minus I plus 5j minus 2k. Okay, so here is a correction. Over here you will have a minus, and option A is the correct answer. Hope you understood this. Next is question number 31. In a quadrilateral ABCD, the point P divides DC in the ratio 1:3 internally, and Q is the midpoint on AC. If this is true, then you have to find the value of lambda. Let's draw the triangle. Quadrilateral. You're given ABCD is the quadrilateral. Okay. So let's say this is A, B. A is having the vector A, and this is the vector for the point B is this. And point P divides DC in the ratio 1:3. So, okay, this is suppose DC. So point P is dividing DC in the ratio 1:3. And Q is the midpoint on AC. Let's draw this AC. Q stands to be the midpoint on AC. If this is true, then you have to find. Let's make the quadrilateral first. So this is the given quadrilateral. C is having the position vector C, and this is the position vector for the D. Okay, right. So now here you have OP is equal to C plus 3D upon 4, because P is dividing this in the ratio 1, CD in the ratio 1:3. Therefore, OP is given by C plus 3D upon 4, that is 1 plus 3, that is 4. And similarly, OQ is equal to A plus C upon D. Now it's given in the question that AB plus AD BC minus 2DC is equal to lambda times PQ. Let's fill. AB is given by B minus A vector plus AD is D minus A. BC is C minus B, and 2DC is given by this. And that is equal to lambda PQ. What is P? From here, I can calculate PQ. This is A plus C upon 2 minus C minus 3D upon 4. So let's solve. This gives you minus 2A minus C plus 3D is equal to lambda upon 4, 2A plus C and minus 3D. Okay, this on solving gives you 2 lambda upon 4 is equal to this, which gives you lambda is equal to -4, or option D is the correct answer. Hope you got that. Next is question number 32. If P is this vector, Q is this vector, if the vectors A and B are orthogonal projections of P on Q and Q on P respectively, then what is the value of this given expression? So here you are given that P is 2I minus 3J plus K and Q is I plus J minus K. Let's find the dot product of it. That is given by this dot I minus plus j minus k. That is equal to 2 into 1, 2 minus 3 minus 1, that is minus 2. Also, let's find out the magnitude of these vectors. The p is equal to 2 square minus 3 square plus 1 square, which is 4 plus 9 plus 1, that is root 14. Next, q is 1 square plus 1 square plus minus 1 square, which is equal to root of 3, right? Now, A is orthogonal projection of P on Q. A is orthogonal projection of P on Q. That means P dot Q upon this can be written as minus 2 by 3 I plus J minus K. Also, B is orthogonal projection of Q on P. So this is Q dot P divided by the magnitude of P square into the P vector. So that's minus 2 by 14. Q dot P, I hope you know how to solve this, right? That's minus 2 by 14. We have already solved it actually. Yes, we have already solved this. So minus 2 by 14 into P is 2I minus 3J plus K. Now, the cross product of A and B is equal to 4 by 42 I plus J minus K multiplied 2I minus 3J plus K. So let's solve that using determinant method. So this is I, J, K, 1, 1, minus 1, 2, minus 3, 1. So that is equal to I, 1 minus 3 minus J, 1 plus 2 plus K minus 3 minus 2. That is equal to 4 by 42 minus 2I cap minus 3J cap minus 5K cap. This is option okay. There is nothing like, wait. So this is equal to 4 by 42. You actually have to find out question number 32. If P is given by this vector, Q is given by this vectors, A and B are orthogonal projections of P on Q and Q on P respectively. You have to find out the value of this expression. Okay, so here you are given that P is 2I minus 3J plus K and Q is I plus J minus K. Let's find the dot product of 2. So this is equal to 2I minus 3J plus K dot I plus J minus K. So this is 2 into 2, 1, minus 3 into 1, 3, minus 1, that is equal to minus 2. So P dot Q is equal to minus Q. Let's find the magnitude of these vectors. So this is equal to 2 square plus minus 3 square plus 1 square, that is root of 14. And Q is given by 1 square plus 1 square plus minus 1 square, which is root of 3. Now you are given that A is orthogonal projection of P on Q. That means P dot Q upon magnitude of Q square into Q is equal to minus 2 by 3 I plus J minus K. Also, B is orthogonal projection of Q on P. That means Q dot P upon magnitude of P square into P is equal to, see, this is equal to minus 2 by 14, 2I minus 3J plus K. Right? Okay. Now, let's find the cross product of the two. So the cross product of the two will give you minus 2 by 3 into minus 2 by 14. This is going to give you 4 by 42. I plus J minus K cross 2I minus 3J plus K. Let's solve it using the determinant method. You have 4 upon 42. I, J, K. 1, 1 minus 1, 2 minus 3, 1. That is equal to 4 upon 42. I cap 1 plus 3, minus 3, sorry. Minus J 1 plus 2. Next is plus K minus 3 minus 2. That's it. So you have 4 upon 42 minus 2I minus 3J cap minus 5K cap. Okay. You have to find out this divided by A dot B. So let's go for the dot product of the two vectors now. So A dot B, this is equal to 4 upon 42. Same thing, I plus J minus K to dot product with 2I minus 3J plus K. So that is equal to 4 by 42. 2 into 2, 1 minus 1. 3 into minus 1, that is equal to minus 3. And this is minus 1. So that is going to give you minus 8 upon 42. Now simply you have to divide them. A cross B upon A dot B. That is equal to 4 upon 42 minus 2I minus 3J minus 5K whole divided by minus 8 upon 42. So this will cancel, and you will have minus 2I minus 2I minus 3J minus 5K whole divided by 2. So let's check. Okay, we can also say this. Let's multiply inside also. This will be 2I plus 3J plus 5K divided by 2. So you have option C as the answer. Hope you understood this question. Next is question number 33. Let A be this vector, B be this vector, C be this vector, or vector X such that X and C dot product is equal to 60 and perpendicular to both A and B is. Okay. First of all, we have 3 vectors. This is A, B, and C. Now it's given that A is perpendicular to X and B is perpendicular to X. That means X is equal to lambda A cross B. Let's find out the cross product of A and B. This is I, J, K, 2, minus 3, 4, 7, 2, minus 3. That gives you lambda I 9 minus 8 minus J minus 6 minus 28 plus K 4 plus 21. That is equal to lambda I 34J 25K. Now we have the dot product of X and C is equal to 60. So lambda I plus 34 lambda J plus 25 lambda K dot product with I plus J plus KC is this. So this is equal to 60. It's given. Let's find the dot product. So lambda into 1 lambda plus 34 lambda into 1, 34 lambda plus 25 lambda into 1, 25 lambda is equal to 60. So this is equal to 60 lambda is equal to 60, or you will get the value of lambda as 1. So therefore, the x factor will become I cap plus 34, j cap plus 25, k cap. So this is the answer to the question, option B. Hope you understood this. Next is question number 34. The shortest distance between this line r is equal to 2I minus 2j plus 3k plus lambda this, and the plane this is equal to 5 is given by. Okay, so the line is given by r is equal to 2I minus 2j plus 3k plus lambda I minus j plus 4k. So also, fine. Also, the plane is given by r is equal to, not r is equal to, it's r dot I plus 5j plus k is equal to 5. Now, I plus, I minus j, this is r, right? So I plus minus j plus 4k dot product with I plus 5j plus k is equal to 1 minus 5 plus 4, that is equal to 0. Therefore, line is parallel to the plane. Correct? Line is parallel to the plane. Therefore, the shortest distance between the line, shortest distance between the line and the plane is nothing but a point. Distance of point 2I minus 2j plus 3k from the plane. Okay, therefore, you are given this r dot I plus 5j plus k minus 5 is equal to 0. So the dot product of the two, that's 2I minus 2j plus 3k dot I plus 5j plus k whole divided by root of 1 plus 5 square is 25 plus 1 square is 1. So this is equal to 2 minus 10 plus, this is equal to 2 minus 10 plus 3. Here I forgot to write minus 5. Yes. Okay. Whole divided by root of 27. So this will cancel and you will see this is the mod. So you will have 10 upon root of 27, or this can be written as 10 upon 3 root 3. So this is the answer to the question, 10 upon root 3, 3 root 3, option C. Hope you understood this. Let's move to the next question, number 35. For the following frequency distribution, variance is approximately equal to. So you have to find out variance for this. Let's make the table for this first of all. This is the class interval. This is the frequency. So first, I'll make xi over here. Xi is 2.5. 0 and 5, the midpoint is 2.5. Here the midpoint is 7.5, 12.5, 17.5, and 22.5. Right? Okay. Also, the sum of the frequency, I'll calculate over here. This will be 20. Now, I'll make the mode column. I'll make it over here. Fi, So frequency multiplied by the mid value. Here it gives me 10. Here it gives me 7.5. This is 7.5. And 12.5 into 10, this is 125. This is 52.5. And this is equal to 45. Sum of that is equal to 240. Okay. Also, mid value square is given by 2.5 square is 6.25. 7.5 square is it's 56.25. And 12.5 square, this is, I'll write it here, 1562.25, and 17.5 square is 918.75. Then you have 22.5 square. This gives you 1012.50. So question number 35, for the following frequency distribution, the variance is approximately equal to. Let's make the table to understand the problem. Here you have the class interval, and I'll make frequency, mid value, xi, frequency into mid value, then is mid value square, then is frequency into mid value square product. So here is 0, 5, and 4, 5 to 10, 10 to 15, 15 to 20, and 20 to 25. So this is 4, 1, 10, 3, and 2. Mid value here is 2.5, 7.5, 12.5, 17.5, and 22.5. So FI, XI in this case, 10, 7.5, 125, 52.5, 45. XI square, this gives me 6.25, 56.25, 156.25, 306.25, 506.25. So here the sum of the frequency is equal to 20. FI, XI, this gives you a total of 240. And last I have to calculate FI, XI square. So 6.25 into 4, this is 25. Similarly, FI, XI square for the next one is 56.25. This is 1562.25. Then 918.75, 112.50. This gives me a total of 3575. Now, variance is given by, variance of x is given by 1. This is the formula, 1 by n sigma fi xi square minus 1 by n sigma fi xi whole square. So 1 by n, that is sum of the frequency. This is 1 by 20. This is 3575 minus 1 by 20 into 240 whole square. So this is 178.75 minus 12 square is 144. This gives you 34.75 as the answer. So you have option C as the answer. Hope you understood this. Next is question number 36. If the mean of the discrete distribution this, then the standard deviation nearest to 2 decimal places is, fine. First of all, the mean of this discrete distribution is 6. How do you find out the mean? That is sum of the terms. That's 8 plus 9 plus 6 plus 5 plus 6 plus 4 plus 6 plus 5 whole divided by number of terms is 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is equal to this. This gives you 43 plus x is equal to 8 6 are 48, or x is equal to 5. So now the data is 8, 9, 6, 5, 5, 4, 6, and 5. Right? Now, fine, this is the data. What do you have to find? Standard deviation. Okay. For that, this is the value for xi. Let's find out xi square. That is equal to 64, 81, 36, 25, 25, 16, 36, and 25. Let's sub add all of this. This is like I'll be adding 64 plus 81 plus 36, 25, 25, 16, 36, and 25. I'll get a 308. So standard deviation of x is given by this 1 by n summation xi square minus x bar square. So that is equal to 1 by 8 into 308 minus 6 square. This is root of 38.5 minus this, that is, or it's equal to 1.58. That is option D. Hope you got this. Next is question number 37. If A and B are events of a sample space such that PA union B is 3 by 4, this whole thing, PA union B is 3 by 4, PA intersection B is equal to 1 by 4, and P A bar is equal to 2 by 3, then you have to find out P A naught intersection B. Let's write down what we are given. It's a bit confusing. First is probability A union B is 3 by 4, and probability A intersection is 1 by 4. Probability of A event not to happen is 2 by 3, which means probability of event A to happen is 1 by 3. I hope you know this. This is 1 minus 2 by 3. That is equal to 1 by 3. Right? Now we know probability A union B is equal to probability A plus B minus probability A intersection B. So probability B minus probability A intersection B is equal to probability A union B minus probability of A. Also, probability, see here, A negative, that A doesn't happen intersection B. This is probability A union B minus probability that A will happen. So now let's fill in the formulas, the values. So this is equal to 3 by 4. Probability of A to happen was 1 by 3. That gives you 5 by 12. Okay. So we have option A as the answer to the question. Hope you understood this. Next is question number 38. Let x and y be two events of the sample space such that px is 1 by 3, px upon y is 1 by 2, and py upon x is 2 by 5. Then which of the following is true? We have probability of x to happen is 1 by 3. Probability x upon y is 1 by 2, and probability y upon x is 2 by 5. Now, let's start. We have probability y upon x is 2 by 5. This is probability y intersection x upon probability of x is equal to 2 by 5, which gives you probability of y intersection x is 2 by 5 into probability of x. What was that? It was 1 by 3. I'll directly multiply this with 1 by 3. I have 2 by 15. Now I'll pick up probability x upon y is probability x intersection y upon the probability of y. Okay. So that means probability, probability x into this is 1 by 2 is equal to, we just calculated this probability x intersection y, this is 2 by 15. So this is 2 by 15 upon the probability of y. So you will have the probability of y is 2 by 15 divided by 1 by 2, or you will have it this as 4 by 15. So probability of y is 4 by 15. Okay, then first thing is wrong. X intersection y, this is 1 by 5. I'll go with the second one now. Probability x union y is 2 by 5. Okay, let's find out probability x union y. This is equal to probability x plus probability y minus probability x intersection y. Probability x was 1 by 3. Probability y, we calculated 4 by 15. Minus this is equal to, we also calculated this is 2 by 15. On solving, you have 5 plus 4, 9 minus 2, that is equal to 7 upon 15. Right. But this is 2 by 5, so even this is incorrect. And probability of y is not 1 by 6. Most probably we have only last option. Let's check. Probability x naught upon y. This is given by probability x naught intersection y upon probability of y. Now this is given by probability of y minus probability x intersection y upon probability of y. Okay, this is 1 minus probability x intersection y upon the probability of y. This is 1 minus 2 by 15 upon 4 by 15, which is equal to 1 minus 1 by 2, or this is equal to 1 by 2. And this is correct. That means option D is the correct answer. Hope you understood this. Let's move to the next question. Question number 39, let A and B be not mutually exclusive events, then probability of A is 4 by 9 and probability A intersection B not is 3 by 7. What is the probability? B upon A. Okay, you are given that probability of event A is 4 by 9 and probability A intersection B naught is equal to 3 by 7. Now, probability A intersection B naught is equal to, okay, wait a minute. A intersection B naught is equal to PA minus P A intersection B. So P A intersection B, this is equal to P A minus this. That is equal to 4 by 9 minus 3 by 7, which gives you 28 minus 27 upon 63, or this is equal to 1 upon 63. Therefore, probability, you have to find out probability B upon A. This is given by probability B intersection A upon the probability of A. That is equal to 1 by 63 upon 4 by 9. This is 1 by 63 upon this. So you have 1 by 28 as the answer. That is option B. Hope you got that. Next is question number 40. If 20 degree of the bolts produced by 20 degree of the bolts produced by a machine are defective, then probability that 4 bolts chosen at random less than 2 bolts will be defective is. Okay. In the question, this is not degree, this is actually percentage over here. All right. Okay. So now 20% of the bolts produced by the machine are defective, then the probability that 4 bolts chosen at random, that means N over here is 4, probability is 20%, that is 20 upon 100 or 1 by 5. And the probability of, see, this is the probability of being defective, and the probability of not being defective is 4 by 5. So the required probability, it says less than 2 bolts are defective. So probability that less than 2 bolts are defective is equal to probability that no bolt is defective plus the probability 1 bolt is defective. So let's go for this. So 4C0 1 by 5 raised to power 0 into 4 by 5 raised to power 4 plus 4C1 1 by 5 raised to power 1, 4 by 5 raised to power 3. 4C0 is 1. So this is 1 into 4 raised to power 4 by 5 raised to power 4 plus 4 into 4 by 5 into 4 by 5 raised to power 3. So this gives you 2 into 4 by 5 raised to power 4. Right? Let's solve this because we don't have any such answer. We have answers in the decimal zone. So this is into 2 into 4 into 4 into 4 into 4 whole divided by 5 into 5 into 5 into 5. That will give you 0.8192. So we have option C as the answer. Hope you understood this. Next is question number 41. In a book consisting of 600 pages, there are 60 typographical errors. The probability that randomly chosen page will contain at most 2 errors is. Okay. So book is containing 600 pages and there are 60 typographical errors. That means lambda is equal to 0.1. Okay. Also, let's note on the formula, probability of x is equal to x is given by e raised to power minus lambda into lambda raised to power x upon x factorial. So here lambda is 0.1. So e raised to power 0.1, 0.1 raised to power x upon x factorial. Now required probability. See, what is that? That the page will contain at most 2 errors. Now this is given by probability x is equal to 0 plus probability x is equal to 1 plus probability x is equal to 2 because it is said that it must contain, may contain at most 2 or errors. So px is equal to 0. This is equal to e raised to power 0.1. Sorry, I missed a minus over here. So this is e raised to power minus 0.1 and this is given by 0.1 upon 0 factorial, this raised to power 0, plus 0.1 raised to power 1 upon 1 factorial plus 0.1 raised to power 2 upon 2 factorial. So that is equal to e raised to power minus 0.1, 1 plus 1 by 10 plus 1 by 200. That's e raised to power minus 0.1, 200 plus 20 plus 1 upon 200. Or this is equal to e raised to power minus 0.1 into 221 upon 200. Or that's equal to 221 upon e raised to power 0.1 into 200. This is answer to the question option B. Right? Okay. Yeah. Hope you got that. Next is question number 42. If M is the foot of the perpendicular drawn from the origin O on the variable line L passing through a fixed point AB, then the locus of the midpoint of OM is. So let's make it. Here's the coordinate axis. M is the foot of the perpendicular drawn from the origin on the variable line L. So let's make that line L is the perpendicular from the origin O. Fixed point AB. So here, let's say this is point Q, any point Q with the coordinates AB. This is M, the foot of the perpendicular. Let's say the coordinates are alpha and beta. And M is the foot of the perpendicular from origin on the variable line passing through a fixed point AB. Then the locus of the midpoint OM. So let this be the midpoint R. This is having the coordinates HK, let's say. So I'm having R, H, K as midpoint on OM. Therefore, the coordinates of HK will be, see, if I'm taking this as alpha and beta, the coordinates of origin are 0 and 0. So HK will be equal to alpha plus 0.2, beta plus 0.2. So this is alpha upon 2, beta upon 2. This gives you alpha is equal to 2H or beta is equal to 2K. So what are the coordinates of M? This is 2H and 2K. Now slope of OM, sorry. slope of OM is given by 2k minus 0 to h minus 0, or that's equal to k upon h. Similarly, slope of MQ is 2k minus b upon 2h minus a. That's it. No further simplification. 2k minus b to h minus a. Now, since both of them are perpendicular to each other, OM is perpendicular to MQ. Therefore, the product of their slopes is equal to minus 1. That means k upon h multiplied to k minus b upon 2h minus a is equal to minus 1. This gives you 2k square minus bk is equal to 2h square minus h into a. Minus minus, this is plus. Okay. Yeah. So you have here 2h square plus 2k square minus ah minus bk is equal to 0. So locus of R with the coordinates h, k is 2x square plus 2y square minus ax minus by is equal to 0. So this is option 2x square plus 2. This is option B. 2x square plus 2y square minus ax minus by is equal to 0. Hope you understood this. Next is question number 43. When the origin is shifted to this point by the translation of coordinate axis, then the transformed equation of this is, okay, so origin is shifted to this point. So let the new coordinates be x is equal to x plus 3 by 2 and y is equal to this. So let's substitute that in this equation. See, this is the original x and y values. So I will substitute them by these values. So this equation now will become 32x plus 3 by 2 square plus 8 into x plus 3 by 2 y plus 3 by 2 plus 32 into y plus 3 by 2 square minus 108x plus 3 by 2 minus 108y plus 3 by 2 plus 99 is equal to 0. So this makes the equation as 32x square plus 3x plus 9 by 4 plus 8 into 2x plus 3 2y plus 3 plus 32y square 3y. Okay, y square plus 3y plus 9 by 4 minus 108x minus 162 108y minus 162 plus 199 is equal to 0. So let's simplify it further. You will have 32x square, 96x, 72 plus 2 into 4xy plus 6x plus 6y plus 9 plus 32y square plus 96y plus 72 minus 108x minus 162 minus 108y minus 162 plus 99 is equal to 0. So you will segregate all the terms. You will get 32x square plus 32y square. Yeah. Plus 8xy minus 63 is equal to 0. So this is what you will get, 32x squared plus 32y squared plus 8xy minus 63. This is option D. So option D is the correct answer. Hope you got that. Next is question number 44. A line L1 passing through A 3, 4 having the slope 1 cuts another line L2 passing through C at B such that AB is equal to AC. If equation of BC is given by this, then the equation of AC is. Okay. Fine. Let's try and draw them first. So here are the three lines. I'll remake it. Fine. This is the point A. This is having the coordinates as 3, 4. A line N1 passing through A 3, 4 having a slope 1 cuts another line L2. So this is line L1 and this is cutting another line L2. L2, fine. This is A, then let's say this is B and this is C. The equation of BC is given to be 2x minus y plus 4 is equal to 0. All right. So line N1 is passing through A, having the slope 1. This is having the slope 1, cuts another line L2 passing through C at B such that AB is equal to AC. So these two lines are equal. If the equation of BC is this, then the equation of AC is fine. First of all, equation of L1 will be given by y minus 4 is equal to 1 into x minus 3 because it's passing through 3, 4 and it's having the slope as 1. So this gives me y minus 4 is equal to x minus 3 or x minus y plus 1 is equal to 0. So let's say slope of AC is m. Since AC is equal to AB, right? Therefore, triangle is isosceles, right? That means these two angles are equal. Angle B is equal to angle C. Therefore, m minus 2 upon 1 plus 2m. See over here. Before discussing this thing, I would like to discuss till here. B was equal to C. That means tangent of angle B is equal to tangent of angle C. And angle B is actually the angle between these two lines, AB and BC. And C is the angle between the lines AC and BC. So that means this can be written as, what is the slope of BC over here first? Slope BC will be equal to 2x is equal to y is equal to 2x plus 4. This gives you the slope of BC is equal to 2. So that means here you can write it as m minus 2 upon 1 plus 2m is equal to 2 minus 1 upon 1 plus 2 into 1, right? Because here the slope of BC is equal to 2. I have used it over here and the slope of this line L1 is equal to 1. So I have used it over here and BC slope is 2. So that's it. Here you can say m minus 2 upon 1 plus 2m is equal to 1 upon 3. So m minus 2 upon 1 plus 2m is equal to plus minus 1 upon 3. That means this can have two values. M minus 2 upon 1 plus 2m can be equal to 1 by 3 or m minus 2 upon 1 plus 2m can be equal to minus 1 upon 3. Here you will get the value m minus 2 is 3m minus 2 is equal to 1 plus 2m or 3m minus 2m is equal to 1 plus 6 or m is equal to 7. Here you will get 3m minus 6 is equal to minus 1 minus 2m, which will give you 5m is equal to 5 or m is equal to 1. Okay. Yeah. But for when m is equal to 1, AC becomes 1 because they have the same slope. AC becomes L1. Therefore, m is equal to 7 only. Now, equation of AC is easy to make. We have the slope as 7 and the point 3, 4 is there, which makes the equation as y minus 4 is equal to 7x minus 3 y minus 4, 7x minus 21, or 7x minus y minus 17 is equal to 0. This makes 7x minus y minus 17 is equal to 0, makes option A to be the correct answer to the question. Hope you got this. Next is question number 45. Angles made with the x-axis by the two lines passing through the point P 1, 2 and cutting the line x plus y is equal to 4 at a distance of root 6 by 3 units from the point P R. Okay, first thing, let the slope of the line be m. So equation of the line will be, since it's passing through 1, 2, so equation of line will be given by y minus 2 is equal to m into x minus 1, or y minus 2 is equal to mx minus m, mx minus y plus 2 minus m is equal to 0. So also we have this line x plus y is equal to 4. Let's solve them. What we'll get for x and y? Let's add them. These two will cancel and you will have mx plus x plus 2 minus m is equal to 4. This will give you m plus 1 into x is equal to 2 plus m, or x is equal to 2 plus m upon 1 plus m, or this. Okay. And on solving, you will get the value of y as 3m plus 2 upon m plus 1. Now it's given angles made with the x-axis by the two lines passing through this point at a distance of root 6 by 3. So according to the question, the distance, I'm applying distance formula also. So m plus 2 upon m plus 1 square minus 1 square minus 1 square plus 3m plus 2m plus 1 minus 2 square is equal to root 6 upon 3. This will give you m plus 2 minus m minus 1 upon m plus 1 whole square plus 3m plus 2 minus 2m minus 2 upon m plus 1 whole square is equal to 6 upon 9. I have squared on the both sides. So you will have here 1 upon m plus 1 whole square plus m upon m plus 1 whole square is equal to 6 upon 9. This will give you 1 plus m square upon m plus 1 whole square is equal to 6 upon 9. Yeah. This can be written as 2 by 3 also. Correct? So let's do the cross multiplication. 3 plus 3m square is equal to 2m square plus 2 plus 4m. This makes m square minus 4m plus 1 is equal to 0. You solving, you will get the roots of the two roots as 2 plus minus root 3. So m can be equal to 2 plus root 3, or m can be equal to 2 minus root 3. So the angles will be, for these values, the angles will be pi by 12 and 5 pi by 12. So that makes option C to be the correct answer. Hope you understood this. Then let's move to the next question, number 46. The straight line x plus 3y minus 9 is equal to 0. And this are congruent if this line passes through which of these points. Okay, so you are given these are the three straight lines. They are congruent. If these lines are congruent, that means if I'm putting them in the matrix form, 1, 3 minus 9, 4, 5 minus 1, and PQ10. The determinant is equal to 0. These lines are congruent. Let's expand this. So on solving this, 1 into 50 plus Q minus 3 into 40 plus P minus 9 into 4Q minus 5. P is equal to 0. This gives me 50 plus Q minus 120 minus 3P minus 36Q plus 45P is equal to 0. Okay. This is going to give me 3P and 45. This is 42P minus 35Q minus 70 is equal to 0. Let's divide both the sides by 7. So 6P minus 6P plus 5Q plus 10 is equal to 0. Okay. That makes, okay, generally, if I'm expressing, this is 5x plus minus 6y. 5x minus 6y plus 10 is equal to 0. So now let's check this passes through. Yeah, here I'm denoting x as q and I'm denoting y as minus p. So x is q and y is minus p. That means we have option A as the correct answer. Hope you understood. See, this was the equation which I got. That means if I'm replacing this, the coefficient of minus 6, P is having the coefficient of minus 6. That means this is Y and this is resembling with X. So X is equivalent to Q and minus P. Hope you understood this. Next is question number 47. Let L belongs to R, the equation 2L minus 3x squared plus 12xy minus y squared represent a pair of lines when which of the following conditions is true. So the given equation 2L minus 3x squared plus 2LXY minus y square is equal to 0 will represent a pair of real and distinct lines if the discriminant is greater than equal to 0. Greater than 0, distinct lines, right? So that means discriminant is greater than 0. What is discriminant? B square minus 4AC. So this is B. Yeah. So this is L square minus 2L minus 3 into minus 1 is greater than 0. Question number 47. For L belonging to R, the equation this plus this minus this represent a pair of lines only when which of the following conditions is true. So you're given the equation 2L minus 3 x square plus 2LXY minus y square is equal to 0. Now this will represent a pair of real and distinct lines if h square is greater than AB, right? What is h square? This is in this equation, h square is L square minus A into B. B is minus 1. So this is good. This should be greater than 0. This gives you L square plus 2L minus 3 is greater than 0. Or let's factorize this. You will have the two factors as L plus 3 and L minus 1 greater than 0. That means in the question it's given that L belongs to the real numbers. So this means that L minus 3 and L can't be greater than minus 3 and greater than 1. So L will have all the real numbers except minus 3 and 1 because these are the two factors. So L can't be greater than 3 or 1, minus 3 or 1. Okay. So you have, according to the question, you have option B as the answer. Hope you understood this. Let's move to the next question then. Question number 48, the centroid of the triangle formed by these two lines is. So if I look at this line, this can further be factorized. Let's pick up this line first. 2y square minus xy minus 6x square is equal to 0. 2xy minus 4xy plus 3xy minus 6x square. I'm splitting the middle term over here. This gives you 2y, y minus 2x plus 3x, y minus 2x is equal to 0, or y minus 2x to y plus 3x is equal to 0. So equation of sides of the triangle, now we get all the three equation of sides of triangle. The three equations now are x plus y is equal to 1. The second, y minus 2x is equal to 0, or 2y plus 3x is equal to 0. Let's solve them. We get. So I'll pick up the first pair, x plus y is equal to 1, y minus 2x, or minus 2x plus y is equal to 0, minus plus, they will cancel and you will have 3x is equal to 0. And for that you will have y is equal to 1. Minus 1, sorry. Sorry, y is also equal to 0, right? Mm, sorry, I did a mistake. This is equal to 1. So you will get, so I'll get 3x is equal to 1, or x is equal to 1 by 3. Solving this, you will get the y is equal to 2 by 3, right? This is the one vertex, that is 1 by 3, comma 2 by 3. Now let's pick up the second pair. I'll pick up 2y plus 3x is equal to 0 and multiply this equation with 2. I have 2y plus 2x is equal to 2. Minus, minus, minus. They will cancel and you will have x is equal to minus 2. And for that, you will solve y, x is equal to minus 2. So y's value will be equal to 3. This is the second coordinate, minus 2 comma 3. And the next one, y minus 2x, I'll multiply this with 2. So 2y minus 4x is equal to 0. 2y plus 3x is equal to 0, minus, minus. They will cancel and minus 7x is equal to 0, which gives you x is equal to 0. And if x is equal to 0, you will have y also equal to 0. So the third vertex is 0, comma 0. So we have the three vertices now. These are the three vertices. That means here is one centroid of the triangle is equal to 1 by 3 plus 0 plus minus 2 whole divided by 3. 2 by 3 plus 3 plus 0 whole divided by 3. This will give you minus 5 by 9 and 11 by 9. So this is minus 5 by 9 and 11 by 9 is option C. Hope you understood this. Let's move to the next question, number 49. 2 points from the set of concyclic points of the circle passing through this, and this is. Okay. First of all, equation of the circle which is passing through these 3 points. Let's form. The equation can be framed by x squared plus y squared, x, y, 1. Here is 1 plus 1, 1, 1, 1. Next 4 plus 1. Here is 9 plus 4. This is 2, 3. And here I have minus 1, 2, and 1, 1. Okay. And this is equal to 0. So let's simplify. This is x square plus y square, 2, 5, and 13. X, y, 1, 1, 1, 1, 2 minus 1, 1, 3, 2, and 1. This is equal to 0. Okay. Yeah. So further, Let's perform R1 as R1 minus R2. You will get, and also I'll perform for, this is for R1, I'll go for R2 as well. So R2, R2 minus R3. And for R3, I'll perform R3 minus R4. Okay, let's perform these transformations. You will have x square plus y square minus 2, x minus 1. Let's have this so that we can see. Y minus 1 and 1 minus 1, that is 0. 2 minus 5, that is minus 3, minus 1, and 2 and 0. Further, you will have minus 8, 1, minus 1, minus 3, 0, then 13, 3, 2, and 1. The determinant is equal to 0. So now I have the 3 zeros over here. Let's expand. This is pretty easy to expand now. Now it will be very much simplified. X squared plus y squared minus 2, x minus 1, y minus 1, minus 3, minus 1, 2, minus 8, minus 1, minus 3. This determinant is equal to 0. Now let's expand it. You will have x squared plus y squared minus 2 into 3 plus 2 minus x minus 1, 9 plus 16 plus y minus 1, 3 minus 8 is equal to 0. This gives you 5x square plus y square minus 2 minus 25 x minus 1 minus 5 y minus 1 is equal to 0. Dividing both sides by 5, x square plus 5 square minus 2 minus x 5 x minus 1 minus y minus 1 is equal to 0. So this will give you x square plus y square minus 2 minus 5x plus 5 minus y plus 1 is equal to 0, or x square plus 5 square minus 5x minus y plus 4 is equal to 0. And you have to find out 2 points from the set of concyclic point on the passing through this is. So I have to check which of these points satisfies the given equation this. When you will check all of them, you will see that you actually have to verify all of them. When you will verify all of them, you will put this point and this point and this point. You will verify and you will check that only option B is satisfying. I'll just show. This is 5. Let's write down the 2 points. 5 by 2 plus root 5 by 2 comma 1 by 2, and the second one is 5 plus root 5 upon 2 comma 1 plus root 5 upon 2. Okay, so this is x, y, x and y. So x square 5 by, this is 5 by 2 plus root 5 by 2 square plus y square is 1 by 4 minus 5 into 5 by 2 plus root 5 by 2 minus 1 by 2 plus 4 should be equal to 0. Let's solve it. 25 by 4 plus 5 by 4 and 2ab. This is 2 5 root 5 upon 2 minus 25 upon 2 minus 5 root 5 upon 2. This on solving will give you plus 4 minus 1 by 4. And these two will cancel first. You have 4 as LCM, 25 plus 5 minus 50 plus 16 plus 1. This is equal to 30. See, there is a mistake. This root was under the hole. I by mistake wrote this. So this is the problematic place. I have a 2 over here, and So the whole sum changes now. See, I'll redo this. Or you can verify actually this comes out to be the correct answer. I'll redo this one. So I will maintain this equation and it points. Okay. So the equation that we got was x square plus y square minus 5x minus y plus 4 is equal to 0. I'll pick up this point first. So this makes 5 by 2 plus root 5 by 2 whole square plus 1 by 2 square minus 5 into 5 by 2 plus root 5 by 2 minus 1 by 2 plus 4 should be equal to 0. This gives you a square, that is 25 by 4 plus 5 by 2 plus b square, that is 5 root 5 upon 2 root 2, right? Minus 25 by 2 plus 5 into root 5 by 2 minus here, sorry. This is minus 1 by 2 plus 4 is equal to 0. And yeah, missed to write this 1 by 4 also. So here is plus 1 by 4. Okay. So these two will cancel out and you have 25 by 4 plus 5 by 2 minus 25 by 2 minus 1 by 2 plus 4 plus 1 by 4. This should be equal to 0. Let's take the LCM, that is 4. So 25 plus 10 minus 50 minus 2 plus 16 plus 1. This gives you the value as 35 plus 17. That's 52 minus 52 upon 4, which gives you a 0. So this point is satisfying. Similarly, you can check for the second point also. It will satisfy the given equation. So option B stands to be the correct answer. Okay. You can rewind the video. You do need to watch this if you want to skip this part. All right. Next is question number 50. Students, before starting with this question, here's a quick reminder to visit our website www.examsnet.com. There you will find similar type of multiple entrance exam question papers for your practice. You can also download our app. The link is available in the description box. So here we have question number 50. If the polar of a point P with respect to a circle of radius r, which touches the coordinate axis and lies in the first quadrant, is x plus 2y is equal to 4r, then the point P is. Okay, first, let point P be x1, y1. Now, equation of the circle with radius r, which touches the coordinate axis and lies in the first quadrant, is given by x minus r square plus y minus r square is equal to r square. If you will open this, you will have x square plus y square minus 2xr minus 2yr plus r square and r square will come to the LHS. So you will be left with only one r square over here. Okay. Yeah. So now further, question number 50. If the polar of a point P with respect to a circle of radius r, which touches the coordinate axis and lies in the first quadrant, is this, then the point P is. Okay, first of all, let's assume the point P to have the coordinates as x1 and y1. Now, the equation of the circle with radius r, which touches the coordinate axis. See, the circle will be or something of this type. It's touching the coordinate axis, right? So the radius is r, that means this is r. So this point becomes r comma 0 and this point becomes 0 comma r. So if we form the equation of given circle with radius r and touching the coordinate axis and lies in the first quadrant. So this equation will be given by x minus r square plus y minus r square is equal to r square, which gives you x square plus r square minus 2xr plus y square minus plus r sorry, plus y square plus r square minus 2yr is equal to r square. This will cancel. And you will be left with x square plus y square minus 2xr minus 2yr plus r square is equal to 0. Now, polar of point P with respect to this circle, with respect to this circle is x square, not x square, x1. This circle I'm talking about, x1 plus y1 minus x plus x1 into r minus y plus y1 into r plus r square is equal to 0. This is x1 y1 minus xr minus x1 r minus yr minus y1 r plus r square is equal to 0. I'll segregate the terms, and you will have here x1 minus r x plus y1 minus r into y is equal to, I'm taking here r common. So I'm taking this x1 r on this side and y1 r on this side and this r square on. So these three terms I'm taking on the right hand side. You will have this as x1 plus y1 minus r. I've taken r common. So, but now this is given that polar of the point with respect to the circle is given by this. So that means these two are equivalent. But it is given that the polar of point P with respect to the above circle is x plus 2y is equal to 4r. So that means, therefore, x1 minus r upon 1 is equal to y1 minus r upon 2 is equal to x1 plus y1 minus r upon 4. Now this gives you x1 minus r is equal to x1 plus y1 minus r upon 4. Also x1 minus r is equal to y1 minus r upon 2. This gives you 4x1 minus 4r is equal to x1 plus y1 minus r, and 2x1 minus 2r is equal to y1 minus r. This is 3x1 minus 3r is equal to y1, and 2x1 minus r is equal to y1. So therefore, 3x1 minus 3r is equal to 2x1 minus r. This gives you x1 is equal to minus 2r, sorry, plus 2r, right? So x1 value is equal to 2r, and y1 was given by 2x1 minus r. So this is 2 into 2r minus r, which is equal to 3r. So the P point is 2r comma 3r. This is it. 2r comma 3r is option C. Hope you understood this. Next is question number 51. If the circles this and this have exactly two common tangents, then the number of positive values of k is. Now you're given two circles over here. Let's write down the equations. You have x square plus y square minus 2x minus 2 into 3 plus root 7 y plus 8 plus 6 root 7 is equal to 0. And the second is x square plus y square minus 8x minus 6y plus k square is equal to 0. The center, it's given by minus half the coefficient of x minus half the coefficient of y, which is g and f. And here also the same thing. The center is minus g comma minus f. So the center in this case, which is C1, this is given by 1 and 3 plus root 7. And the center C2, this is given by 4 comma 3. Similarly, let's say the radius formula, that is equal to root of g square plus f square minus c. So R1 is equal to root of 1 square plus 3 plus root 7 square minus 8 plus 6 root 7. Here R2 is equal to root of 4 square plus 3 square minus k square. So this is, let's solve. 1 plus 9 plus 7 plus 6 root 7 minus 8 minus 6 root 7. This will cancel. And you will have root of 9, that is equal to 3. R2 is equal to 16 plus 9, that is 25 minus k square. Okay. Now let's calculate C1 and C2. C1, the coordinates were 1, 3 plus root 7. C2 had the coordinates as 4, 3. So C1, C2 will be given by root of 4 minus 1, that is equal to 3 square, plus 3 minus 3 plus root 7, which is equal to minus root 7 square. That is equal to 9 plus 7, or that is equal to 4. So C1, C2 is equal to 4. Also, let's calculate R1 plus R2. This is 3 plus this. 3 plus root of 25 minus k square. Okay, so this is definitely, see, if we are looking from here, C1, C2, this 4 is less than. So I'm adding 3 to something over here. This is 4 is definitely less than this one. So that means C1, C2 is less than R1 plus R2. Also, you are given over here that this is having two common tangents. So C1, C2 is less than R1, R2. C1, C2 was this. I'll start from here. So 1 is less than root of 25 minus k square. See, okay. You are given in the question that it is having exactly two common tangents. Therefore, C1, C2 is less than R1 plus R2. Therefore, 4 is less than 3 plus root of 25 minus k square. Though squaring both sides, 1 is less than 25 minus k square, or k square is less than 24. So, the possible values, see, the possible values of k are like 0, 1, 2, 3, 4. 5 is not there because 5 square is 25. So that means you have these values, right? You can't have, it is said in the question that k belongs to integers, so you can't have the rational values for the k. So these are the possible values for k. Let's check out which is the correct answer. The number of possible values of k are 1, 2, 3, 4, 5, 6, 7, 8, and 9. Therefore, you have option C as the answer. Hope you understood this. Let's move to the next question then. Question number 52. The circle S is equal to 0 cuts the circle C1 and C2, which are given by these equations orthogonally. If the common chord of S is equal to 0 and C1 is equal to 0 is given by this, then the center of the circle S is. Fine. First of all, we'll assume this equation for the circle S. Let's say this is given by x squared plus y squared plus 2gx to fy plus c is equal to 0, and C1 is x squared plus y squared minus 8x minus 2y plus 16 is equal to 0. C2 has the equation x squared plus y squared minus 4x minus 4y minus 1 is equal to 0. Now, since S is cutting these two circles orthogonally, since X cuts C1 and C2 orthogonally, therefore minus 8F minus 8G minus 2F is equal to C plus 16. Let's say this is 1. And from the second equation, you have minus 4G minus 4F is equal to C minus 1. Let's say this is equation 2. So from both of these equations, let's multiply this with 2. You have minus 8G minus 2F is equal to C plus 16 minus 8G minus 8f is equal to 2c minus 2 plus minus plus. So this will cancel and you have a 6f is equal to minus c plus 18. Okay. Yeah. So this is question number 52. The circle S is equal to 0 cuts the circle C1, which is given by this equation, and C2, which is given by this equation, orthogony, that is at 90 degree. If the common chord of S is equal to 0 and C1 is equal to 0 is given by 2x plus 13y minus 15 is equal to 0, then the center of the circle S is equal to 0 is. Okay, first thing, let's assume the equation of the circle S be given by x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. C1 has the equation as x squared plus y squared minus 8x minus 2y plus 16 is equal to 0, and C2 x squared plus y squared minus 4x minus 4y minus 1 is equal to 0. Now, S is cutting C1 and C2 orthogonally. S cuts C1 and C2 orthogonally, for which the conditions is, see, the two circles, they are, if I'm having the equation of the two circles, which is given by x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. And the second circle, x squared plus y squared plus 2g dash x f dash y plus c dash is equal to 0, then the condition for orthogonality is condition of orthogonality is given by 2g d dash plus f dash is equal to c plus c dash. So according to that, over here for C1, the condition will be minus 8f minus 2f is equal to c plus 16. And for the circle C2 is minus 4g. Sorry, here is g, not f. Minus 4g minus 4f is equal to c minus 1. Let's say this as 1 and 2. From these two equations, from 1 and 2, what you get is minus, adding both of, subtracting both of them, you get minus 4g plus 2f plus minus, plus minus and plus, minus 4g plus 2f is equal to 17. Let's say this is equation 3. Now, common chord, with the common chord of these two circles, common chord of S and C1, common chord of S and C1, what is the general formula for that? If I'm having these two circles, say x squared plus y squared plus 2g x plus 2fy plus c is equal to 0, and the second circle is x1 square y1 square plus 2g dash x 2f dash y plus c dash is equal to 0. So the common chord is given by 2g minus g dash plus 2x plus 2f minus f dash plus c minus c dash is equal to 0. This is the common chord. Okay, according to that, over here, this will be for circle. Let's write on the circle. S was given as x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. And C1 was x squared plus y squared minus 8x minus 2y plus 16 is equal to 0. So the common chord of both the circles is, see, it will be 2g minus 8 plus 8, because minus minus will be plus, x plus 2f plus 2y. I forgot to write y over here. So 2f plus 2y plus c minus 16 is equal to 0. You are given the common chord is given by this equation, 2x plus 13y minus 15. But common chord is given by 2x plus 13y minus 15 is equal to 0. So if I'm saying this is equation 4 and 5, from 4 and 5, they both coincide. So you have 2g plus 8 upon 2 is equal to 2f plus 2 upon 13 is equal to c minus 16 minus 15. Also, you have, from here you can say 13g minus 2f is equal to minus 50. Okay, so let's say this is equation 6. Now solving equation 3 and 6. This was equation 3 and this is equation 6. Now let's solve both of them. You have 13g minus 2f is equal to minus 50 and minus 4g plus 2f is equal to 70. Minus 4g plus 2f is equal to 17. Okay, so let's add both of them. You have 9g is equal to, that's minus 33, which gives you g is equal to, like they will get at 3 minus 11 upon 3. Okay, and if you will solve, you will get the value of f to be minus 7 by 6. You got the value of g and f. That was the center of the circle. So the center of circle S, that is given by minus g minus f. This is equal to 11 by 13 and 7 by 6. Here's the correction. You will solve. This is plus 7 by 6. So minus g, that's 11 by 3, and minus f is minus 7 by 6. 11 by 3 minus 7 by 6 is option B. So you have option B as the correct answer. Hope you understood this. Next is question number 53, the equation of the circle passing through the point of intersection of the two orthogonal circles S1 and S2, which are given by these equations, and passing through the point 1, comma, minus 1 is. So here you have the circle S1, which is given by x squared plus y squared plus kx minus 4y minus 1 is equal to 0. And S2 is given by 3x cube. It's actually x squared, not cube. So 3x squared plus 3y squared minus 14x plus 23y minus 15 is equal to 0. So x squared plus y square. This will be given by minus 14 by 3. I'm dividing both sides by 3 by x plus 23 by 3y minus 5 is equal to 0. Since both the circles are orthogonal, therefore, we discussed in the last question itself the condition for orthogonality. According to that, this will be 2 into minus k by 2 into 7 by 3 plus 2 into minus 23 by 6 is equal to minus 1 minus 5. So you have 2 into minus 7k upon 6 minus 46 upon 6 is equal to minus 6, which gives you minus 7k upon 6 minus 46 upon 6 is equal to minus 3. Or this is equal to this, which is minus 18 plus 46 upon 6. This is gonna give you minus 7k is equal to minus 18 plus 46 is minus, no, this is plus 28, which gives you k's value as minus 4. So you got the value of k as minus 4. Therefore, the S1 becomes x square plus y square minus 4x minus 4y minus 1 is equal to 0, and S2 is x square plus y square minus 14 by 3x plus 23 by 3y minus 5 is equal to 0. Okay, now equation of the circle which is passing through the intersection of both of these circles. Equation of circle passing through intersection of both of these circles is x square plus y square minus 4x minus 4y minus 1 plus lambda into x square plus y square minus 14 by 3x plus 23 by 3y minus 5 is equal to 0. Now you are given that this circle passes through minus 1, minus 1. Since above circle passes through minus 1, so this will be minus 1 square 1 plus 1 plus 4 plus 4 minus 1 plus lambda 1 plus 1 plus 14 by 3 minus 23 by 3 minus 5 is equal to 0. Which one solving will give you? This will cancel, and you have here 9 plus lambda into, this is minus 3 and minus 19 upon 3 is equal to 0. 9 plus lambda into minus, okay, this is 18 minus 18 minus 19, sorry, minus 9 minus this upon 3 is equal to 0. Sorry, here is 9, not 19. Okay, so I'll rewrite this step again. You have 9 plus lambda into minus 3, and this is 3, 14 minus 23 plus, this is equal to 0. 9 plus lambda into minus 9 minus 9 upon 3 is equal to 0. This gives you lambda minus 18 upon 3 is equal to 0, or this is 9 minus 6 lambda is equal to 0. Now you got this value. So equation of required circle is x square plus, see from here you get the value of lambda is equal to 9 by 6 or 3 by 2. Okay, now the equation of the required circle becomes x square plus y square minus 4x minus 4y minus 1 plus 3 by 2 x square plus y square minus 14 by 3 x plus 23 by 3 y minus 5 is equal to 0. So on opening this up, this will be 2x square plus 2y square minus 8x minus 8y minus 2 plus 3x square plus 3y square minus 14x plus 23y minus 15 is equal to 0, which will give you 5x square, 5y square, 22x plus 15y minus 17 is equal to 0. So this is the equation of the required circle. 5x square plus 5y square minus 22x plus 15y minus 17 is equal to 0 is option C. So you have option C as the correct answer. Hope you got that. Next is question number 54. Consider the parabola y squared plus 2x plus 2y minus 3 is equal to 0, and you have to match list 1 with list 2. Here is list 1 and list 2. I'll pick up all the options of list 1 one by one and see what it matches with. So, okay, first of all, you are given the parabola, that is y square plus 2x plus 2y minus 3 is equal to 0. So let's make it like y plus 1 whole square minus 1, 2x minus 3 is equal to 0. So y plus 1 whole square is equal to 4 minus 2x, which gives you y plus 1 square is equal to minus 2 into x minus 2. So what is the vertex over here? 2 comma minus 1. Axis in this case is given by y plus 1 is equal to 0, and focus is minus a plus 2 minus 1, which gives you, so here a is minus 1 by 2. So minus 1 by 2 plus 2 comma minus 1, which is equal to 3 by 2 comma minus 1, right? And here the directrix is given by x minus 2 is equal to 1 by 2, which gives you x is equal to 2 plus 1 by 2, that is equal to 5 by 2, or 2x minus 5 is equal to 0. Now see, here was your a, that is vertex. Vertex is 2 comma minus 1. So this is matching with the, okay, 2x minus 5. 2x minus 5 is your directrix. So this is option 3. 3 by 2 comma minus 1, that was your focus. So this matches with 2. So y plus 1 is equal to 0. This is your axis, and this is number 4. 2 comma minus 1. That's your vertex. So this is number 1. So A is with 3, B is with 2, C is with 4, and D is with 1. That is option A. You have option A as the correct answer. Hope you got that. Let's move to the next question then. Question number 55. The normal at a point on the parabola y square is equal to 4x passes through 5, comma 0. If there are two more normals to this parabola which passes through 5, comma 0, the centroid of the triangle formed by the feet of the three normals is. See, here we have the parabola as y square is equal to 4x. If we compare it with the general equation, y square is equal to 4x, we have a is equal to 1 over here. Now, we know that centroid, we know that centroid of the triangle formed by the co-normal points on a parabola lies on its axis and its coordinate axis. We know that centroid of the triangle formed by the co-normal points on the parabola lies on its axis, and its coordinates are given by 2 by 3 h minus 2a comma 0, where h and k is the point through which all point through which or normal passes. Therefore, coordinate of the centroid is given by 2 by 3, 5 minus 2 into 1, comma 0. That is equal to 2 by 3, 5, and this is 3, 0, which is equal to 2, comma 0. Question number 55. The normal at the point on the parabola y is equal to 4x passes through 5, comma 0. There are two more normals to this parabola which passes through 5, comma 0. The centroid of the triangle formed by the feet of these three normals is. Fine. You are given the parabola's equation is equal to 5, y square is equal to 4x. If I compare it with the general equation, y square is equal to 4ax, I will get the value of a is equal to 1. Now, we know that centroid of the triangle formed by the co-normal points by the co-normal points on a parabola lies on its axis, and its coordinates are. 2 by 3 h minus 2a comma 0, where h and k, where hk is the point through which all normals pass. Therefore, coordinates of the centroid are 2 by 3. HSC, it's given in the question that this point is 5, 0. So this is 5 minus 2 into 1, 0. That is equal to 2 by 3 into 3, which is 2, 0. So that means we have option D as the answer. Hope you understood this. Next is question number 56. The centricity of an ellipse which is passing through 3 root 2, root 10 with the foci this and this is. Fine. So here, if I take the equation of the ellipse as x square upon a square plus y square upon b square is equal to 1. Now it's given it passes through this. Therefore, since it passes through 3 root 2, root 10. Therefore, 3 root 2 square is 18 upon a square plus 10 upon b square is equal to 1. Let's say this is 1. And the foci are given by plus minus 4 is equal to 0. That is AE is equal to 4, or E square is equal to 16. Or this can be written as a square into 1 minus b square upon a square is equal to 16. That is a square minus b square is equal to 16, right? Or b square is equal to a square minus 16. Let's say this is equation 2. Now from both the equations 1 and 2, you have 18 upon a square plus 10 upon a square minus 16 is equal to 0, or 18 a square minus 16 plus 10 a square is equal to a square minus this. You'll have 18 a square plus this becomes 28 a square minus 288 is a raised to power 14 minus 16 a square. This is 12 a square minus 288 is equal to a raised to power 4. Or, sorry, this is going to be added, right? This is 44. So a raised to power 4 minus 44 a square plus 288 is equal to 0. Let's split the middle term. You will have the two factors as a raised to power 4, a raised to power 2 minus 36 into a raised to power a square minus 8 is equal to 0, which gives you a square is equal to 36, or a square is equal to 8. I can't take, I take a square is equal to 8. I can't take a square is equal to 8 because b square is equal to a square minus 16. So find the minor axis. This can't be greater than major axis. Therefore, b cannot be greater than a. Correct? Fine. Now, a square, that was equal to 16. E square is equal to this. A square was 8. Sorry, 36. So this gives you E as 4 upon 6 or 2 upon 3. That's it. The value of E comes out to be 2 by 3, which is option B. Hope you got that. Next is question number 57. If the product of the length of perpendiculars drawn from the foci to the tangent this of the ellipse x square upon a square plus y square upon b square is equal to 1 is 9, then you have to find out the eccentricity of the ellipse. Now we know that product of length of perpendicular drawn from foci to the tangent of ellipse, which is given by x square upon a square, y square upon b square is equal to 1 is nothing but b square. So here, length is equal to 9. Therefore, b square is equal to 9. And equation of the tangent is y is equal to minus 3 by 4x plus 3 root 2. That means 3 root 2 is equal to plus minus root of a square minus 3 by 4 square plus b square. Okay, now squaring both the sides, you have 18 is equal to 9 by 16 a square plus 9. That gives you 2 minus 1 is equal to a square upon 16, or a square is equal to 16. You know, e is given by, I have both the values now. E is given by root of 1 minus b square upon a square, root of 1 minus 9 upon 16, which is root 7 by 4. So you have option D as the answer. Hope you understood this question. Next is question number 58. The equation of the hyperbola whose eccentricity is root 2 and the two foci are 16 units apart is. First of all, let the equation of the hyperbola is given by x square upon a square minus y square upon b square is equal to 1. Here you are given eccentricity is equal to root 2 and distance between the two foci, that is 2AE, is equal to 16, which is 2 root 2 a is equal to 16, or a is equal to 8 divided by root of 2, right? This will be 4 root 2 only. This is the value of a. Now eccentricity is given by 1 plus b square upon a square. This is root 2. This is 1 plus b square. A square is 16, 2. That is equal to 32, which gives you the value as root 2 into 32 is equal to 32 plus b square, or b square is equal to question number 57. If the product of length of perpendiculars drawn from the foci to the tangent y is equal to minus 3 by 4x plus 3 root 2 of the ellipse, this is 9, then eccentricity of that ellipse is. We know that the product of length of perpendicular drawn from the foci to the tangent of the given ellipse, which is x square upon a square, y square upon b square is equal to 1, is b square. Therefore, the length, here the length is given to be 9, which means this is equal to b square. Also, equation of the tangent is given to you as y is equal to minus 3 by 4x plus 3 root 2. So if this is the equation of the tangent, that means this formula is this. If I'm saying this 3 root 2, this is equal to root of a square m square plus b square, where m is the slope of the tangent. M is equal to minus 3 by 4 in this case. So this becomes 3 root 2 is equal to a square. I don't know. I have to find out. And this is equal to minus 3 by 4 whole square. And b square is equal to 9. Right? That is going to give you, squaring both the sides, 18 is equal to 9 by 16 a square plus 9 or 9 by 16, a square is equal to 9, which will give me a square is equal to 16. Fine. Also, the centricity is given by the formula root of 1 minus b square upon a square, which is 1 minus root of 9 minus this. That is going to give me root of 7 by 4. So you have option D as the answer. Hope you understood this. Next is question number 58. Equation of the hyperbola with the centricity root 2, foci 16 units apart is. First of all, let's say equation of hyperbola is x square upon a square minus y square upon b square is equal to 1. You are given eccentricity is equal to root 2 and the distance between the two foci is equal to 16. Fine. So, okay, you have this 2 into a into root 2 is equal to 16, which gives you a is equal to 16 upon 2 root 2. That is 4 into root 2. That is the value of a. Now, also, eccentricity square is equal to 1 minus 1 plus b square upon a square. So, this is equal to 2 is equal to 1 plus b square is, I don't know, a square is this. So, that is equal to 1 is equal to b square upon 16 into this is 32. So, b square is equal to 32, which gives you b is equal to 4 root 2 again, and that is equal to a. Now the equation of the hyperbola becomes equation of hyperbola is x square upon a square, which is equal to 32 minus y square upon b square, which is equal to 32 again, that is equal to 1. Or x square minus y square is equal to 32. You have option D as the answer. Hope you understood this. Then let's move to the next question, number 59. You have 3 points A, B, C. They are collinear. Then the ratio in which this point divides the line segment BC is. Okay, first you are given that these 3 points, they are collinear. If they are collinear, then 3 points are collinear. If they are collinear, which means 3 plus 1 upon 5 minus 3 is equal to 2 minus 0 upon k minus 2 is equal to t minus 7 upon minus 2 minus t. This gives you 2 is equal to 2 upon k minus 2, right? See, 4 by 2 is equal to 2 this gives you 2 is equal to 2 upon k minus 2. That is equal to t minus 7 minus 2 minus t. Now, this gives you from here, you get the value of k as 3 and using the second one, that is t minus 7 minus 2 minus 3 is equal to 2. T minus 7 is equal to minus 4 minus 2t, or 3t is equal to 3, which gives you t is 1. Fine, you got the value of k and 3. So the point B becomes 3, 2, 1, and C becomes 5, 3, minus 2. And P becomes 1, 1, 4. Okay, now this divides the line segment in which ratio? Let the ratio be lambda is to 1. This is B. Coordinates 3 to 1. C. Coordinates 5, 1, minus 2. And this is P. The coordinates are 1, 1, 4. Let this divide the line in the ratio lambda is to 1. So according to that, 5 lambda plus 3 upon lambda plus 1 is equal to 1, right? Okay. 5 lambda plus 3 is equal to lambda plus 1, or 4 lambda is equal to minus 2, which gives you lambda is equal to minus 1 by 2. Right, this is what you had to find out. Lambda is equal to minus 1 by 2, which is option B. Hope you understood this question. Next is question number 60. The direction cosines L, M, N of two lines are satisfying these two equations. If theta is the angle between the lines, then what is the value of cos theta? Fine, you have the two lines as 3L plus M plus 5N is equal to 0. Also, 6MN minus 2NL plus 5LM is equal to 0. Okay. From here, I will see M is equal to minus 3L minus 5N. Now, 6Mn minus 2NL plus 5LM is equal to 0 becomes 6N into minus 3L minus 5N minus 2NL plus 5L minus 3L minus 5N is equal to 0. Let's open the bracket. You have minus 18NL minus 30N square minus 2NL 15N square 25LN is equal to 0. Okay, so dividing both sides by 2, you have, and minus, okay, let's say minus 2 only. Fine. So you will have 15L square plus 30N square plus 45NL is equal to 0. Yeah, there is no need to divide by minus 2. Actually, this is there. Question number 60, the direction cosines L, M, N of two lines are satisfying these two equations. If theta is the angle between the lines, then what is the value of cos theta? You have the given lines as 3L plus M plus 5N is equal to 0. Here you have M is equal to minus 3L minus 5N. And the second one is 6Mn minus 2NL plus 5LM is equal to 0, which gives you 6N minus 3L minus 5N minus 2NL plus 5L minus 3L minus 5N is equal to 0. That gives you minus 18L NL minus 13N square minus 2NL minus 15L square minus 25NL is equal to 0. Okay. Fine. So this gives you minus 13N square minus 15L square. And you have this as minus 20. So this gives you minus 45 NL is equal to 0. Or this gives you, so let's divide both the sides by 15 minus 15. You will have L square plus 3NL plus 2N square is equal to 0. Let's factorize it. You will have the two factors as L plus N and L plus 2N is equal to 0, which gives you L is equal to minus N or minus 2N. These are the two possible values for L. So if I'm taking L is equal to N or L is equal to minus N, in this case, minus 3N plus M plus 5M is equal to 0. Here M becomes equal to minus 2N. So the direction ratios are minus N minus 2N and N. Or this is equal to 1, 2, minus 1. In the second case, when L is equal to minus 2N, you have minus 6N plus M plus 5N is equal to 0. This gives you M is equal to N. So the reduction ratios in this case are minus 2N, N, N, that is minus 2, 1, 1. So cos theta, these are the two direction ratios. So cos theta is given by 1 minus 2, or 1 into minus 2 plus 2 into 1 plus minus 1 into 1 whole divided by root of 1 plus 4 plus 1 root of 4 plus 1 plus 1. That is equal to cos theta. I have to write actually the mod. So this is given by mod of minus 2 plus 2 minus 1 whole divided by root of 9 into root of 6, that is equal to, sorry, this is root of 6 again over here. Root of 6 into root of 6, that is equal to this, or this will give me 1 by 6 only. Right. So I have option C as the answer. Hope you got that. Let's move to the next question, number 61. A tetrahedron is having the vertices as O, A, B, and C. These are the 4 vertices. If theta is the angle between the faces OAB and ABC, then cos theta is equal to. Fine. First of all, let's consider the face OAB. Equation of the plane. OAB is given by, I'm writing this using the matrix method. This is x minus 0, y minus 0, z minus 0, 1 minus 0, 2 minus 0, 1 minus 0, 2 minus 0, 1 minus 0, 3 minus 0 is equal to 0. That gives you x, y, z, 1, 2, 1, 2, 1, and 3. That's equal to 0. So this makes it x into 6 minus 1 minus y 3 minus 2 z 1 minus 4 is equal to 0, or 5x minus y minus 3 z is equal to 0. Now equation of the plane ABC. Similarly, equation of plane ABC is given by x minus 1, y minus 2, z minus 1, 2 minus 1 minus 1 minus 1. That is 1 minus 2, 3 minus 1, 1 minus 2, 2 minus 1 is equal to 0, which makes it x minus 1, y minus 2, z minus 1, 1 minus 2 minus 1 minus 1, 2, 1 is equal to 0. Let's expand it. You have x minus 1 plus 2 minus y minus 2, y plus 4 plus z minus 1 minus 1 minus 2 is equal to 0. So this becomes x minus 1 minus 5y plus 10 minus 3z plus 3 is equal to 0. Or x minus 5y minus 3z plus 12 is equal to 0. Let's say this is equation 2. Okay. So we have the two equations, as this is equation 1. Angle between the planes represented by these two equations. Angle between the planes represented by equation 1 and 2 is cos of theta is equal to 5 into 1 minus plus 1 into minus 1 minus 5 plus minus 3 into minus 3 whole divided by root of 5 square 21 plus 1 square plus minus 3 square, that's 9 into 1 plus this is equal to, that's 10 plus 9 whole divided by 35 into root of 35, which is equal to 19 upon 35. So 19 upon 35 is option B. So this is the correct answer. Hope you understood this. Let's move to the next question, number 62. Log 1 plus x is equal to x minus x squared by 2 plus x cubed by 3 plus x4 by x raised to power 4 by 4 till infinity, and log limit x approaching 0. This whole expression is equal to k. Then what is the value of 12k? Okay. In this question, first you have limit x approaching 0, log of 1 plus x raised to power 1 plus x upon x square minus 1 by x is equal to k. So limit x approaching 0, 1 plus x, this can be written like this, log 1 plus x minus x upon x square is equal to k. So I'm applying, so this is 0 upon 0 form. I'm applying L Hospital's rule using L Hospital rule. You have limit x approaching 0 log 1 plus x plus 1 minus 1 upon 2x minus k is equal to k. Okay. So this becomes 1 upon 2 raised to power x approaching 0 log of 1 plus x upon x. Question number 62. If log 1 plus x is equal to x minus x squared by 2 plus x cubed by 3 plus this till infinity, and limit x approaching 0 log 1 plus x raised to power x divided by x squared minus 1 upon x is equal to k, then 12k is equal to. See, in this question, you are given, let's start from here, limit x approaching 0 log 1 plus x raised to power 1 plus x whole divided by x square minus 1 by x is equal to k. This can be written as limit x approaching 0, 1 plus x log 1 plus x. I'm taking the LCM minus x whole divided by x square is equal to k. See, this is 0 upon 0 form. So I'm applying L Hospital's rule over here using L Hospital's rule. So you have limit x approaching 0, 1 log 1 plus x plus 1. First function to derivative of second plus second function to derivative of first. So plus 1 minus 1 upon x. This is 2x. Okay. This is equal to k. Right. Now I'll take the 2 outside. So 1 by 2 limit x approaching 0. I have log 1 plus x upon x is equal to k. That is equal to 1 by 2 into 1 is equal to k, because this is equal to 1. Okay. So that means you have the value of k as 1 by 2. You have to find out 12k, which is equal to 6. That's it. You have option C as the answer. Hope you understood this question. Next is question number 63. If fx is equal to k when x is equal to 1 and it's given by this expression for x not equal to 1. This is continuous on 0 to infinity. Then k is equal to. See, the question is given that it is continuous from 0 to infinity. That means continuous at 1 as well. Now, fx is continuous at x is equal to 1. Therefore, k is equal to limit x approaching 1, 9x minus 1 into root of x minus 1 whole divided by 3x square plus 2x minus 5. So k is equal to limit x approaching 1, 9 raised to power x into this will be x raised to power 3 by 2 minus 9x minus root x plus 1 whole divided by 3x square plus 2x minus 5. Okay. This becomes k is equal to limit x approaching 1. This can be written as 9, 3 by 2, x raised to power 3 by 2 minus 9 minus 1 by 2 root x plus 0. I'm using L Hospital's rule over here. Whole divided by 6x plus 2. See, this was 0 upon 0 form. So I'm using here L Hospital's rule. Fine, this becomes k is equal to, now this will be 27 by 2 minus 9 minus 1 by 2 upon 6 plus 2. That becomes 13 minus 9 upon 8, or this is equal to 1 by 2. So you have option D as the correct answer. Hope you got that. Let's move to the next question. Question number 64, let gx not equal to 0 and first derivative of gx is not equal to 0, fx not equal to 0, derivative not equal to 0, and capital Fx is equal to fx gx, capital Gx is equal to f dash x g dash x, and f dash capital F dash x is equal to this, then what is the value of hx plus kx? Okay, I'll start with you're given that fx is equal to f of x into g of x, right? And f dash of x is equal to f dash x gx plus fx. Yeah, plus fx into g dash x. Okay, from here, I'm concatenating these two things, gx into hx. Fine. Question number 64, let gx not equal to 0 and g dash x not equal to 0. Fx is not equal to 0 and f dash x is not equal to 0. Let's write it here. You are given that fx not equal to 0, f dash x not equal to 0, gx not equal to 0, and g dash x not equal to 0. Further, you have fx is equal to fx, capital fx is equal to small fx into small gx, and capital gx is equal to the product of their derivatives. Further, you have f dash x is equal to gx hx, and that's it. This is further equal to fx into kx. You have to find out the sum of hx plus kx. Okay, fine. I'll start. You are given fx is equal to f of x into g of x. Let's find the derivative. First function to derivative of second, and second function into derivative of first. So first derivative into second function plus fx into g dash x. And you know gx is equal to f dash x into g dash x. Therefore, f dash x is equal to, it's given gx into hx. Therefore, I have to find out hx. Hx can be written by g f dash x upon g x. This is equal to f dash x plus into gx plus fx into g dash x whole divided by this, right? So you can write for the simplification, I will not write x now, I'll simply write f and g. So dividing first these two things, you will have g upon g dash plus this will give you f upon f dash. Again, you have f dash x is equal to fx into kx. I have to find out kx, that is equal to f dash x upon fx, and f dash x, it was f dash x gx plus fx g dash x whole divided by fx was equal to fx gx. So this will be given by gg will cancel, and you will have f dash upon f plus g dash upon g. Therefore, you have the value of hx as g upon g dash plus f upon f dash, and kx value as f dash upon f g dash upon g. Let's add both of them. You have hx plus kx is equal to f dash f plus g dash f upon f dash plus g dash upon g. So that's it. You have option D as your answer. Hope you understood this question. Next is question number 65. Y is equal to x sine inverse x upon this plus log 1 minus sine 1 minus x squared. Then dy by dx is equal to. So here you have y is equal to x sine inverse x upon 1 minus x square root plus log of 1 minus x square log. Let's find out the derivative. Dy by dx will be given by denominator square, that is 1 minus x square. Question number 65. If y is equal to x sine inverse x upon 1 minus x square root plus log 1 minus x square root, then dy by dx is equal to. Okay, I'll directly start with finding the derivative. Okay, we have to find out the derivative. Let's directly go with that. So dy by dx is, I'm considering this as the function, first one. So this is equal to denominator square. So 1 minus x square root, this will become 1 minus x square into denominator multiplied by derivative of the numerator, which is 1 into sine inverse x plus x upon root of x square minus numerator into derivative of denominator. So numerator is x into sine inverse x into derivative of denominator is root of 1 minus x square into 2x plus derivative of this is equal to 1 by 2, 1 minus x square into minus 2x. These two will get cancelled, and here also, there was 2, sorry, and this 2 will also get cancelled. You will be left with 1 by x square root 1 minus x square sine inverse x plus x minus minus, it will be plus x square sine inverse x upon 1 minus x square minus x. Okay, because this will be cancelled. So this is minus 1 upon this. Right? Now I'll take 1 minus x square common. So this will be 1 upon 1 minus x squared. It will be taken common. You will be left with here 1 minus x square root into sine inverse x plus x plus sine square sine inverse x whole divided by 1 minus x square minus x. So these two x will get cancelled and you have 1 upon 1 minus x square. I'm taking the LCM. This is 1 minus x square sine inverse x plus x square sine inverse x whole divided by root of 1 minus x square. So see, these two minus x square sine x plus x square sine inverse x, they will cancel out and you will be left with sine inverse x upon 1 minus x square raised to power 3 by 2. So this is answer to the question. Sine inverse x upon this. This is actually this is equal to option B. So here you have option B as the correct answer. Hope you understood this. Let's move to the next question then. Question number 66. Let fx and gx be two differentiable functions such that fx is equal to this and gx is equal to this. You have to find the difference between the two. So here you have fx is equal to x square plus first derivative of this multiplied by x plus second derivative at x is equal to 2. So f dash x, if I found out the first derivative, this is 2x plus g dash of 1. Right from here, this is equal to 1. Yeah, let this be number 1. Similarly, second derivative of the function x will be given by 2 and the third derivative of it will be equal to 0. Now, again, I'm having gx is equal to x square into f of 1 plus x into f dash x plus f double dash x. So g dash x will be given by 2x f1 plus f dash x plus f double dash x plus f triple dash x. Fine. So if I put x is equal to 1, at x is equal to 1, so you have g dash 1 is equal to 2 into f1 plus f dash 1 plus the second derivative at 1. This is equal to 0. We just calculated. So let it be that only. Let this be equation 2. So let's put x is equal to 1 in equation 1 as well. In equation 1, put x is equal to 1. You will get f dash 1 is equal to 2 plus g dash of 1. Let's say number 3. Now equation 2 and 3 from equation 2 and 3 we get g dash 1 is equal to 2f1 plus 2 plus g dash 1 plus 2 or 2f1 plus 4 is equal to 0, which gives you f1 is equal to minus 4. Let's say this as equation 4. Now again, let's find the second derivative of g. So this is going to give you 2f1 plus f double dash x plus f double dash x again plus f x into third derivative of x. So this is equal to 2f1 plus 4, that is equal to minus 4 plus 4, or this is equal to 0, right? Therefore, you have fx is equal to, which was x squared plus x into g1 plus second derivative of g at 2. Yes. Okay. So this is equal to x squared plus xg1, because this is going to give me 0 plus 0. Now again, I'm putting x is equal to 1. Put x is equal to 1. You have f of 1 is equal to 1 plus g of minus 1, that is equal to minus 2. So 1 plus this is the g of 1 is equal to minus 3, right? Fx, which was equal to x squared plus x, and g of 1, that is equal to minus 3. I'm putting over here. Yeah, so this is equal to x squared minus 3x. Also, gx is equal to f of 1 into x squared plus f into f dash x plus the second derivative of x. So this is equal to minus 2x squared plus x into 2x minus 3 plus 2. That's minus 2x squared plus 2x squared minus 3x plus 2. This is equal to 2 minus 3x. So you have to find out fx minus g of x. That is equal to x squared minus 3x minus 2 plus 3x minus 2. Sorry, minus 2. Okay. So this is equal to x squared minus 2. That's it. X squared minus 2 is option D. Hope you understood this. Next is question number 67. If the area of the circle increases at the rate of 1 upon root of pi square units per second, then the rate in units per second at which the perimeter of the circle changes when the perimeter is root pi units is. So first, let A be the area. P be the perimeter. So dA by dt is, according to question, this is equal to 1 by pi, and dt by this actually is equal to 1 by pi. Area is pi r square for the circle. You know this, right? So also 2 pi r, see, I'm finding the derivative. So 2 pi r into dr by dt is equal to 1 by root pi, or this gives me dr by dt is equal to 1 by 2 pi r into root of this. Now, you know, perimeter is equal to 2 pi r. Area was pi r square. So derivative of p with respect to r is given by 2 pi into dr by dt, or that is 2 pi into 1 upon 2 pi r into root of r, which gives you 1 upon r into root of r. Correct? So that is equal to 1 upon 1 upon 1 upon this multiplied by root of pi. See, why is this thing? Because perimeter is equal to root of pi, right? Which means 2 pi r is equal to root of pi. And from here, you have r is equal to root of pi upon 2 pi. Okay, right. So, yeah, that means this is equal to, this will cancel out and you will have 2 units per second. So the answer to the question is option A. Hope you understood this. Let's move to the next question, number 68. Let A be the fixed positive real number and n be the arbitrary constant. For the curve y is equal to this, if the length of the subnormal at any point alpha comma beta is proportional to alpha square, then n is equal to. Fine. Here you have the equation y is x raised to power n divided by a raised to power minus n minus 1. Let's find the derivative. Dy by dx is given by n into x raised to power n minus 1 divided by a raised to power n minus 1. Therefore, length of subnormal is y into dy by dx. This is equal to x raised to power n upon a raised to power n minus 1 into n into x raised to power n minus 1, a raised to power n minus 1. This gives you n into x raised to power 2n minus 1 divided by a raised to power 2n minus 2. Right? Now, length of subnormal at alpha comma beta is n into alpha upon a raised to power 2n minus 2. Now it's given that length of the subnormal is proportional to a square. Given that length of subnormal is proportional to alpha square, this gives you 2n minus 1 is equal to 2, or this gives you n is equal to 3 by 2. So that's it. You have to find out the value of n square, which is 3 by 2. Option D is the correct answer. Hope you understood this. Right? Let's move to the next question then. Question number 69. Question number 69. In each of the choices given below, a function and an interval are given. The correct choice having a function and the associated interval for which the Lagrange mean value theorem is not valued is. Okay. First of all, I'll assume let the function be 2x minus 1 upon 3x minus 4, if I'm taking this function for the interval 1 to 2. Since fx is not defined, fx is not defined for x is equal to 4 by 3. See the denominator 3x minus 4 cannot be equal to 0, which means x cannot be equal to 4 by 3. So fx is not defined for x is equal to 4 by 3, which belongs to this interval. 4 by 3 belongs to the interval 1 by 2. Okay, so that means Lagrange theorem is not applicable for option 3. C, right? That means we have option C as the answer. Hope you understood this. Let's move to the next question. Question number 70. Students, before starting with this question, here is a quick reminder to visit our website www.examsnet.com. There you will find similar type of multiple entrance exam question papers for your practice. You can also download our app. The link is available in the description box. So here we go with the question number 70. It says, let Px be a polynomial of degree 3 having the value at extreme value at x is equal to 1. Limit x approaching 0. This expression is equal to 6. Then the derivative of p with respect to x at x is equal to 1 by 2 is. All right, let's start with the sum. You are given that px is a third degree polynomial, which means let px is equal to ax cube plus bx square plus cx plus d. Now let's find the derivative with respect to x. That can be written as p dash x is equal to 3ax square plus 2bx plus c. Now, you are given that this is having the extreme value at x is equal to 1. So, function px has extreme value at x is equal to 1. So, therefore, p dash 1 is equal to 0, which means 3a plus 2b plus c is equal to 0. Now, we are given that limit x approaching 0, px plus 4 plus 2, px plus 4 upon x square plus 2 is equal to 6, which can be written as limit x approaching 0, px was equal to ax cube, bx square, cx plus d plus 4 whole upon x square plus 2 is equal to, okay, plus 2 is equal to 0. 6, sorry. Okay. So now I can write it as limit x approaching 0. This is a x plus b plus c upon x plus d plus 4 upon x square is equal to 6 minus 2, that is equal to 4. Now, since the value of the limit is finite, that is 4, since value of limit is finite, therefore c is equal to 0 and d plus 4 is also equal to 0, which gives you d is equal to minus 4, which makes the limit x approaching 0, ax plus b is equal to 4, which makes b is equal to 4. So we have the value c is equal to 0, d is minus 4, and b is equal to 4. Now let's put b is equal to 4 and c is equal to 0 in equation 1, which is equation 1. This one is the equation 1, 3a plus 2b plus c is equal to 0, which makes 3a plus 8 plus 0 is equal to 0, or a is equal to minus 8 by 3, which makes a whole equation, that is expression px as minus 8 by 3 x cube plus 4x square minus 4. C is 0. So that's minus 4. That's it. Now let's find the derivative. dp by dx. dp of x by dx is equal to minus 8 by 3 into 3x square plus 4 into 2 into x, which makes it as minus 8x square plus 8x. Now this derivative at dp upon dx at x is equal to 1 by 2 is equal to minus 8 into 1 by 2 whole square plus 8 into 1 by 2, which is making it minus 2 plus 4, that is 2. So the answer to the question is option A, that is 2. Hope you have understood this question. Let's move to the next question then. Question number 71, you have to find out the integral of this expression. Let's go with this. So let's say this is equal to some I. Let's split it up. you can write it as this is equal to integral of y square plus y raised to power 4 by 3 plus y raised to power 2 by 6, that is 1 by 3, whole divided by y into 1 plus y raised to power 2 by 3 dy. Right. So this is equal to integral of, I'll take y raised to power 4 by 3 common from here now. This can be written as y raised to power 2 plus 1 plus y raised to power 1 by 3 whole divided by y into 1 plus y raised to power 2 by 3 dy. This is equal to y raised to power, here was 2 by 3. Sorry, no. Okay, this is equal to integral of y raised to power 4 by 3 into y square plus 1 upon y into 1 plus y raised to power 2 by 3 plus y raised to power 1 by 3 upon y into 1 plus y raised to power 2 by 3. Is this slight change? Actually, this is why it's supposed to be y raised to power 2 by 3. Y raised to power 2 by 3. See, what happened over here is y raised to power 2 minus 4 by 3 gives you y raised to power 6 minus 4 by 3, which is y raised to power 2 by 3. So this is got to be y raised to power 2 by 3. Okay. And this is dy. So this becomes, this is equal to y raised to power 4 by 3 minus 1. This gives you y raised to power 1 by 3. And these two will cancel out. Plus y raised to power 1 by 3 minus 1 upon 1 plus y raised to power 2 by 3 dy. So now this is equal to y raised to power 1 by 3 plus 1 upon 1 by 3 plus 1 plus y raised to power minus 2 by 3 upon 1 plus y raised to power 1 by 3 whole raised to power 2 dy. So this is equal to 3 by 4 y raised to power 4 by 3 plus okay, this is equal to integral of y raised to power. See, this can be written as, I'll write 3 over here. Derivative of y raised to power 1 by 3 upon 1 plus this whole square. Question number 71, you have to find out the integral of the given function. All right, here's a small correction in the question. It is y square in this case. Let this be equal to I. I'll start it from here itself. So this integral can be written as y square plus y raised to power 4 by 3 plus y raised to power 2 by 6. That is y raised to power 1 by 3 whole divided by y 1 plus y raised to power 2 by 3 dy. Now this can be written as y raised to power 4 by 3. I will take common. Inside, I will have y raised to power 2 by 3 plus 1 plus y raised to power 1 by 3 whole divided by y into 1 plus y raised to power 2 by 3 dy. Okay. Next, I'll split it. This can be written as integral of y raised to power 4 by 3 into 1 plus y raised to power 2 by 3 divided by y into 1 plus y raised to power 2 by 3 dy plus y raised to power 1 by 3 divided by y into 1 plus y raised to power 2 by 3 dy. These two will cancel and you will have integral of 1 by 3 dy plus integral of y raised to power minus 2 by 3 y raised to power minus 2 by 3 whole divided by 1 plus y raised to power 2 by 3 dy. Okay, now let's find out. This is easy. This is y raised to power 1 by 3 plus 1 upon 1 by 3 plus 1 plus. See, y raised to power 2 by 3, I can write it like this. Derivative of y raised to power minus 2 by 3 is actually the derivative of y raised to power 1 by 3 over here. See, if I'm finding the derivative integral of this, you will get this upon 1 plus y raised to power 2 by 3 dy. Okay. So this is equal to 3 by 4 y raised to power 4 by 3 plus 3. Now this is tangent inverse of y upon 3, because this is a derivative of y 1 raised to power 3. Now this is 1 upon 1 plus y square form. That is the integral is equal to tan inverse of y. So this is 3 tan inverse 1 by 3 plus the constant c, which makes it like 3 by 4 cube root of y raised to power 4 plus 3 tan inverse cube root of y plus c. So this is answer to the question. Let's check. You have option A as your answer. Hope you got that. Let's move to the next question, number 72. For k belonging to 1 to infinity, the integral of 1 upon 1 plus k cos x dx is equal to. Okay, so here you have, let's say this is equal to some integral I. So this can be written as integral of, I'll open up cos x. This can be written as 1 plus k 1 minus tangent square x by 2 upon 1 plus tangent square x by 2 dx, which further can be written as, I'll take 1 plus tangent square x by 2 up. So 1 plus tangent square x by 2 is equal to secant square x by 2, 1 plus tan square x by 2 minus plus k minus k into tan square x by 2 dx. Now, if I put this tangent of x by 2 is equal to t, the derivative secant square x by 2 into 1 by 2 dx is equal to dt. This gives me secant square x by 2 dx is equal to 2 dt. That makes the integral now. The integral now becomes twice of integral dt. See this integral from 1. This becomes integral is equal to 2 into integral of dt k plus 1 minus k minus 1 t squared. That is 2 upon k minus 1 I have taken common. Integral of dt upon root of k plus 1 upon k minus 1 square minus t square. Okay, so this is equal to 2 upon k minus 1 into 1 by 2 log, not log right now, 2 upon k minus 1, 1 upon root of k plus 1 k minus 1 into log of root of k plus 1 k minus 1 plus t root of k plus 1 k minus 1 minus t plus the constant c. This makes it 2 will cancel, and I will have here this, see, this will cancel out with this, and you will be left with root k minus 1. So this becomes root of k square. This is k minus 1 into k plus 1. This is root of k square minus 1 log of root of k plus 1 plus root of k minus 1. Tangent of t was equal to plus t was equal to tangent x by 2 whole divided by k plus 1 minus this. Okay, this is, sorry, multiplied by tangent of, because I have taken the LCM, right? So k minus 1, root of k minus 1, the numerator and the denominator will cancel, and you will be left with this. Let's write it properly once again. So this is equal to 1 upon root of k square minus 1 log of root of k plus 1 plus root of k minus 1 tangent x by 2 upon root of k plus 1 minus root of k minus 1 tangent x by 2 plus the constant c. Now let's look at the options, which is the correct one. That is, let's see which is the correct one. Is it option B or D? Of course, it's B. So we have option B as the answer. Hope you got that. Next is question number 73. Integral problem again. E raised to power minus 3x into x squared plus sine 4x dx is equal to what? So let's say this is equal to some I. Now this can be written as integral e raised to power minus 3x into x squared plus dx. Integral of e raised to power minus 3x into sine 4x dx. This is equal to x square into e raised to power, I'm solving the integral, e raised to power minus 3x upon minus 3 minus of integral of minus 1 by 3 e raised to power minus 3x into 2x into dx plus e raised to power minus 3x upon 9 plus 16 into minus 3 sine 4x minus 4 cos 4x plus the constant c. Fine, I'll solving it further over here. So this will be 1 by 3 minus 1 by 3 x square e raised to power minus 3x plus 2 by 3 x into e raised to power minus 3x upon minus 3 minus of integral of minus 1 by 3 e raised to power minus 3x into 1 dx okay. Plus e raised to power minus 3x upon 25 minus 3 sine 4x minus 4 cos 4x plus c. So this is equal to 1 by 3 minus 1 by 3 e raised to power 2 e raised to power x raised to power 2 e raised to power minus 3x minus 2 by 9x into this minus 2 by 27 e raised to power minus 3x plus minus minus 3 upon 25 e raised to power minus 3x sine 4x minus 4 upon 25 e raised to power 3x minus 3x cos 4x plus the constant c. So that's equal to e raised to power minus 3x. I'm taking common x square by 3 plus 2x by 9 plus 2 by 27 plus 3 upon 25 sine 4x cos 4x plus the constant c. So now let's look at the option. It matches with the option A. So this is the correct answer to the question. Hope you understood this. Then let's move to the next question. Question number 74. If integral of 2 raised to power 2 into x raised to power 12 plus 5x raised to power 9 upon 1 plus x cube plus x raised to power 5 whole cube dx is equal to this expression, then m minus L upon R is equal to. Okay, I'll start with the given expression integral. That is, let's say this is equal to I. This is 2x raised to power 12, 5x raised to power 9 whole divided by 1 plus x cube plus x raised to power 5 whole cube dx. So now this is equal to, I'm taking it, I'll write the numerator as such, 2 into x raised to power 12 plus 5 into x raised to power 9 whole divided by x raised to power 5. This is 1 upon x raised to power 5 plus 1 upon x square plus 1 dx. Okay, so this can be further. This is 2 into x raised to power 12 plus 5 into x raised to power 9. Wait, I'm missing with something. I have missed this cube actually. So this was whole cube, right? Okay, so this becomes x raised to power 15. 1 plus 1 upon x square plus 1 upon x cube, x raised to power 5, whole cube dx. Now I'm putting 1 plus 1 upon x square plus 1 upon x raised to power 5 is equal to t. Let's find out the derivative. So this is minus 2 upon x cube minus 5 upon x raised to power 6 dx is equal to dt. So you have I is equal to this, I becomes, see, this is equal to, if I'm dividing this, so this becomes, the numerator becomes 2 raised to power, 2 into x raised to power 12 upon x raised to power 15 plus 5 into x raised to power 9 upon x raised to power 15 whole divided by 1 plus this, right? So this is equal to 2 raised, okay, I'm solving it further here. This is equal to integral of 2 upon x cube plus 5 upon x raised to power 6 whole divided by 1 plus 1 upon x raised to power 2 dx. Right. So now this integral becomes, this is equal to minus dt upon t cube. Right. So integral simply, this is equal to minus into t raised to power minus 3 by 2 plus 1 upon minus 3 plus 1 plus the constant c, which is equal to t raised to power minus 2 upon minus 2 into minus, this is 1 by 2 into 1 upon t square plus the constant c. So let's fill in the value of t now. You had 1 by 2, t was equal to 1 plus 1 upon x square plus 1 upon x raised to power 5 whole square plus c. Right? Now, integral becomes, this is x raised to power 10 upon 2 into right? This was the integral. If I'm comparing with this one, question number 74, if integral of this given function dx is equal to this, then m minus L upon R is. So you are given this integral. This is equal to this particular expression. I'll start with integral, which is given. Let this be equal to integral of 2x raised to power 12 plus 5x raised to power 9 whole divided by 1 plus x cube plus x raised to power 3 whole cube dx. I'll take x raised to power 5 common from the denominator. You will have 2x raised to power 12 plus 5x raised to power 9 divided by x raised to power, see, 5 3s are 15. And I'll be left over here with x raised to power 1 by 5, 1 upon x square plus 1 cube dx. So this further can be written as 2 into x raised to power minus 3 plus 5 into x raised to power minus 6 upon 1 plus 1 upon x square plus 1 upon x raised to power 5 dx. Now I'll put 1 plus 1 upon x square plus 1 upon x raised to power 5 is equal to d. Let's find out the derivative. So the derivative will come out to be 0. Then you have minus 2 upon x cube minus 5 upon x raised to power 6 dx is equal to dt. See, this matches with the numerator. So that becomes, and now the integral I becomes is equal to minus dt upon t cube. That is equal to minus t raised to power minus 2 upon minus 3 plus 1, which makes it 1 upon 2 raised to power t square plus the constant c. And now let's fill what was t square. That was equal to, the integral becomes equal to 1 plus 1 upon x square, 1 upon x raised to power 5 whole cube plus, it was, sorry, square, not cube. This is square now. See, it's 2 over here. So this becomes, this is equal to 1 by 2 into, I'll take x raised to power 10 here. So this is x raised to power 10 plus x raised to power 8 3, sorry, plus x raised to power 5. Here is, I'll redo the step. I'll do it over here. This is 1 by 2 x raised to power 5, 1 upon. This is x raised to power 5 plus x raised to power 3 plus 1 whole square. So that is equal to 1 by 2 into x raised to power 10, and the denominator will have 1 plus x cube plus x raised to power 5 whole square plus the constant c. If I compare it with the given equation, this, let's write it down. So this was equivalent to x raised to power m upon L into, give me a minute. Okay, 1 plus x cube plus x raised to power 5 r. So here you can clearly see m is equal to 10, L is equal to 2, and r is equal to 2. You have to find out m minus L upon r, that is 10 minus 2 upon 2, which gives it 4. Okay. So here you have option B as the answer. Hope you understood this. Then let's move to the next question, number 75. Limit n approaching 0, 1 plus n square into 1 plus 2 square upon n square till 1 plus n square upon n square is equal to whole raised to power 1 by n is equal to what? Okay, so you are given this limit. Let's say this is equal to some L. So if you are saying this is equal to some L, then log of L is equal to limit n approaching infinity 1 by n. Log L is equal to limit n approaching infinity 1 by n. If I'm taking log on both sides, so that means log 1 plus 1 upon n square plus log 1 plus 2 square upon n square, log of 1 plus n square upon n square is equal to, I'm writing here, limit n approaching infinity 1 by n summation r is equal to 1 till n log of 1 plus r upon n square. Right now, I'll be discussing one formula over here. You know this, limit integral of 0 to 1 log 1 plus x square dx is equal to x into log 1 plus x square from 0 to 1 minus integral 0 to 1 x into 1 upon 1 plus x square into 2x dx. That is equal to log, see, that's equal to log, I'm putting the intervals now, log 2 minus 2 into limit 0 to 1 x square upon 1 plus x square dx, that is equal to log 2 minus 2 integral 0 to 1 1 minus 1 upon 1 plus x square dx. So this is equal to log 2 minus 2x minus tangent inverse x from 0 to 1, that is log 2 minus 2, 1 minus tangent inverse of 1 is pi by 4. So this is 1 minus pi by 4. So over here, this becomes log 2 minus 2 plus pi by 2, or this is log 2 minus 2 plus pi by 2. So therefore, the log becomes e raised to power e log 2 into e raised to power pi by 2 minus 2, or this is equal to 2 into e raised to power pi by 4 upon 2. So now let's check with the options. You have option D as the correct answer. Hope you understood this. Then let's move to the next question. Question number 76. Integral of pi by 4 to pi by 2, 3 dx upon 1 plus e raised to power root 8 sine x minus 3 pi by 8 is equal to. I'll see, before starting the question, I would like to discuss one formula, that integral limit a to b fx dx can be written as limit a to b f of a plus b minus x dx. So I'll be using this formula for the denominator. So this will become integral of pi by 4 to pi by 2, 3 dx whole divided by 1 plus e raised to power root 8 sine of pi by 2 plus pi by 4 minus x minus 3 pi by 8 dx. Okay, dx I have written. So this is equal to integral pi by 4 to pi by 2, 3 dx upon 1 plus e raised to power root 8 sine of 3 pi by 8 minus x dx. This is equal to integral of limit pi by 4 to pi by 2, 3 dx upon 1 plus e raised to power minus this. I'm changing the sign. So this is x minus 3 pi by 8 now. So this is equal to integral limit pi by 4 to pi by 2, 3 e raised to power 8 sine x minus 3 pi by 8 upon e raised to power 8 sine x minus 3 pi by 8. Let's say this as equation 2 and this one as equation 1. Sorry, not this one. I'm taking this one as equation 1, which is given to you. Okay. So now adding both the equations 1 and 2. Adding 1 and 2. See, I hope you have got this thing. See, this is equal to e raised to power minus 1 by 8, which can be written as integral of pi by 4 to pi by 2, 3 dx upon 1 plus 1 upon e raised to power root 8 sine x minus 3 pi by 8. So I've taken the LCM over here. Now adding both the equations 1 and 2, you get 2i is equal to 3 will be taken common. Integral pi by 4 to pi by 2, 1 dx. That is equal to 3 into this x, which is equal to 3 into pi by 2 minus pi by 4, that is 3 into pi by 4. This is, wait, 3 into pi by 4. That's it. And what you had to find out, this was equal to 2i. Integral is equal to 3 pi by 8. So this is the answer to the question. 3 pi by 8 is option D. Hope you understood this question. Then let's move to the next question, number 77. Question number 77. If the area of the region bounded by y is equal to cos x, y is equal to sin x, at x is equal to pi by 4 and x is equal to pi is bisected by a line x is equal to a, then sine a plus pi by 4 is equal to. Let's try to understand the problem by drawing a figure. So here's the coordinate axis. Okay, here this is x and the y-axis. So x-axis is given by, sorry, y is equal to cos x is given by this curve. This is pi by 2. This is the curve for cos x, and sin x is given by this. This is pi, and see, cos x is 0 for pi by 2 and sin x is maximum, that is 1 at pi by 2. This is pi by 4. All right, I think we have drawn everything now. Fine. Now the area of the region bounded by this and this, x is equal to pi by 4 and x is equal to pi, is bisected by the line x is equal to a, then sine a plus pi by 4 is. Now it's given that the area is bisected by this line. So according to the question, I'll start from here. According to the question, integral of pi by 4 to a sine x minus cos x dx is equal to integral of a to pi sin x minus cos x dx. This is equal to, let's find the integral, it's pretty easy, minus cos x minus sin x pi by 4 to a. This is equal to minus cos x minus sin x a to pi. So this is equal to, I'm filling the limits, minus cos a minus sin a plus 1 by root 2 plus 1 by root 2 is equal to minus of minus 1. This is equal to 1 plus cos a plus sin a. That makes root 2 minus 1 is equal to 2 cos a plus sin a, or root 2 minus 1 upon 2 is sin a plus cos a, which makes it root 2 minus 1 upon 2 into root 2. I'm multiplying both sides by 1 by root 2. So this becomes this. This can be written as cos pi by 4 sin a into cos pi by 4 plus cos a into sin pi by 4, which is nothing but sin a plus pi by 4. So this is equal to root 2 minus 1 upon 2 root 2. That's it. This is answer to the question. Let's check. Option C is the correct answer. Hope you understood this. Then next is question number 78. If the family of curves y is equal to this, where a and b are arbitrary constants, represents a general solution of the differential equation this, then df upon dx is equal to. Okay, I'll start with y is equal to a into e raised to power 4x plus b into e raised to power minus x. Let's differentiate it with respect to x. So dy by dx is equal to 4ae this minus this. Let's say number 1 and this one number 2. Again differentiating with respect to x, dy by dx square, you have 16ae raised to power 4x plus b e raised to power minus x. Let's say it number 3. On adding 1 and 2, you get y plus dy by dx is equal to 5ae 4 raised to power x. That gives you ae 4 raised to power e raised to power 4x is equal to 1 by 5y plus dy by dx. Let's say this as number 4. Now from equation 1 and 4, we get y is equal to 1 by 5y plus 1 by 5 dy by dx plus b e raised to power x. This gives you b e raised to power minus x is equal to 4 by 5y minus 1 by 5 dy by dx. Fine. Now from, say, let's say this as equation 5. From equation 3, 4, and 5, what we get is d square y upon dx square is equal to 16 by 5y plus 16 by 5 dy by dx plus 4 by 5y minus 1 by 5 dy by dx. That makes this is equal to 4y plus 3 dy by dx, or d square y upon dx square is equal to 3 dy by dx. It is minus d square y upon dx squared minus 3 dy by dx minus 4 is equal to 0. Therefore, the function f is equal to d square y upon dx squared minus 3 dy upon dx minus 4y. Let's differentiate with respect to x. So df by dx becomes equal to d cube, that's the third derivative of y with respect to x, minus 3 d square y upon dx square minus 4 dy by dx. So this is answer to the question. Let's check. You have df by dx is equal to this. Option P. Hope you understood this. Next is question number 79. If the length of the subtangent at any point Pxy on the curve fxy is equal to 0 is given by x plus 7y squared, then fxy is equal to. Okay, we know one thing. Length of subtangent is given by y upon dy by dx is equal to y upon dy by dx. Question number 79. If the length of the subtangent at any point Pxy on the curve fxy is equal to 0 is given by this equation, then fxy is equal to. We know one thing, that length of subtangent is given by y upon dy by dx. Now the length of the subtangent is given by this. So this is equal to x plus 7y square, which gives you dy by dx is equal to y upon x plus 7y square, which gives you dx upon dy as x plus 7y square upon y. Right? So dx upon dy is equal to x by y plus 7y, which makes it dx by dy minus 1 by y, x is equal to 7y. Right? Therefore, if is e raised to power minus 1 by y dy. That's equal to minus e raised to power log of y, or that is equal to 1 by y. So the solution is given by, so the solution is given by x into 1 by y is equal to integral of 7y into 1 by y dy plus c. So that is x upon y is equal to 7y plus c, or x is equal to 7y square plus cy. So f of xy is nothing but 7y square plus cy minus x is equal to 0. That's it. You have option C as the correct answer. Hope you understood this. Next is the last question of the paper, question number 80. If the general solution of the differential equation this minus this is equal to 0, then f x, y, c is equal to 0. Then the value of c such that f11c is equal to 0 is fine. You are given these two. This is the equation y minus x plus 1 d y minus y plus x plus 2 dx is equal to 0. So let's open up. You will have y dy minus x dy plus dy minus y dx minus x dx plus 2 dx is equal to 0. This gives you y dy plus dy minus x dy plus y dx minus x dx plus 2 dx is equal to 0. Now on integrating both the sides, you will have y square upon 2 plus y minus xy minus x square upon 2 plus 2x minus c is equal to 0. Therefore, the function fx y comma c is equal to y square by 2 minus x square by 2 minus xy plus 2x plus y minus c, right? And f of 1 comma c is equal to 0, it is given. This makes the function as 1 by 2 minus 1 by 2 minus 1 plus 2 plus 1 minus c is equal to 0. That makes this 2 will also cancel. Wait, yeah. So c is equal to 2. That's it. C is equal to 2 is option C. So you have option C as the answer to the question. Hope you understood this. So students, with this, we have completed all the 80 questions of this paper. Hope you understood them well. And don't forget to visit our website, www.examsnet.com. You can also download our app. The link is available in the description box. So, a very best of luck to your exams. That's all for this paper. Bye.